The event begins at 8 a.m. Pacific Time. 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 Please welcome the host of SiteTech Global, Brian Fischler.
Welcome to day 2 of the 3rd annual SiteTech Global. In case you're keeping score, yes, I'm wearing the same pants as yesterday. This is a free virtual global event about accessibility and the technologies like AI that are having a huge impact in the lives of the blind and visually impaired. I'm your host, Brian Fischler. If my voice sounds familiar to you, that's because hopefully you've heard me on my podcast, That Real Blind Tech Show. I lost my vision due to retinitis pigmentosa, and I'm told some of you like descriptions, so I believe I'm a man in my mid-40s. I miss my hair because I loved rocking a mullet, and I recently was told the mullet is making a comeback, so I'm sad I'm going to miss out on that. I'm coming to you recorded from a studio in New York City, and yes, I've got to do it again because how many chances in life do you actually get to do it? Not live from New York, it's Site Tech Global. Once again, thank you for indulging me. I'm sitting in front of a Times Square-sized billboard that has the logos of Site Tech Global and the Vista Center in dark blue across it. Site Tech Global is a production of the Vista Center for the Blind and Visually Impaired. The Vista Center is a Silicon Valley-based not-for-profit that's been serving the blind and low vision for 75 years. All proceeds from Site Tech Global are used to support the Vista Center. You might not know this, but we have thousands of people tuning in from over 70 countries. The best thing about Site Tech Global is it's free and it's virtual, which means anyone and everyone can join and learn. Now I'm going to take you through a little bit of a walkthrough of the site. Be aware that there's no login. All you have to do to access all the content is land on this landing page. We ask people to register so we can keep them updated, but anyone can join even without registration and enjoy all the content. Right now, you're on the main page for Site Tech Global, which is also the virtual main stage. The content is coming to you in a YouTube embedded player, and remember, all of the content, including me, has been pre-recorded. We will be publishing all of these sessions to the Site Tech Global YouTube channel, so you'll be able to enjoy them on demand. On the agenda page, you'll find the lineup and links to all of the sessions, along with links to the breakout rooms, which will take you to Zoom. Remember, the Zoom seminars are live, and you can always catch the main stage sessions later on YouTube. Our first session today comes to us from a team that needs no introduction at Apple. Our moderator is Matthew Panzarino, Editor-in-Chief of TechCrunch. Full disclosure, I own an iPhone, iPad Pro, iPad Mini, Mac Air, iMac, AirPods, AirPod Pros, and AirPod Maxes. I did draw the line at the Apple cloth, as I kind of had to draw the line somewhere. So you could say I'm a little bit of a fanboy of Apple. I mean, Apple brought us iOS and VoiceOver on the smartphone. No big tech company has done more for the blindness community than Apple. So thank you for that, Apple.
A deep dive into Apple's industry-leading screen reader VoiceOver. Moderator Matthew Panzarino, speakers Dean Hudson and Ariba Kamal.
Thanks, Brian. Okay, well, I'm so happy to be here at Site Tech Global to talk about kind of different issues around accessibility and some of the new technological advancements. I'm so happy to have a couple of participants here from Apple. I'd love for you both to introduce yourselves and what you do at Apple. Perhaps Ariba, we'll start with you.
Yeah, it's great to be here. My name is Ariba. I am our product manager for accessibility at Apple, and I work really closely with our engineers, our designers, to build vision, hearing, mobility, and cognitive accessibility features across our devices.
Thank you, Ariba. And Dean.
Yeah, I'm Dean Hudson. I've been at Apple for a little while, started in engineering, and now working in the Policy Social Initiatives group. I'm an accessibility evangelist here at Apple, working with various teams to make sure our products are accessible.
Excellent. Thank you. So happy to have you both with us. I'm glad you could take the time. There's lots of places we could start, but I think one good launch pad for us would be to talk about what's new in vision accessibility this year at Apple. I know we have a lot of new features being launched every year, and just kind of what's the bleeding edge of vision accessibility in the new versions of iOS and new hardware this year.
Yeah, Matthew, like you said, accessibility is something that we are always working on, and there's always new and exciting updates for our users with disabilities. And this has been an exceptional year for accessibility at Apple. So within Vision, I wanted to point out two things today. One, there's been some fantastic updates to our magnifier app, which is built into every iPhone and iPad for our low vision and our blind users. And this year, on iPhone and iPad devices with the LiDAR scanner, we introduced a tool called detection mode. Now, detection mode is a handy place for our blind users to find a whole set of helpful utilities. And one of them is called door detection. It's new this year. And what it does is, if you're a blind user and you're getting out of a taxi cab to explore a new neighborhood spot, door detection is going to tell you how many doors there are in front of you and read the text and symbols around the door so that you can find the right door to your destination. And it can also describe the color and the shape of the door, how far you're standing from it, whether the door is open or closed, and if it's closed, how you can open it. And you can combine it with people detection to distance socially and image descriptions to get some more descriptions of your surroundings. And we're getting some really great feedback from our users who are blind that the tool is helping them just go and explore new places around them. The second thing I wanted to mention for folks is our screen reader voiceover has been around for a while, but it keeps getting better. And this was an incredible year for voiceover because we actually added over 20 new languages and locales for our users across different geographies and our users globally. And we also added nifty new customization options. So even for languages that we previously supported, there's a host of new voices, such as the eloquence voices that are super popular amongst veteran screen reader users. And you can customize voiceover even more with the updates we've made this year. There's also a text checker. So if you're a voiceover user on the Mac and you have any duplicative spaces, you have any miscapitalized letters, the kind of visual typos that might be hard to catch, VoiceOver can now help you catch them. So really a great year all around for vision accessibility.
Oh, thank you for that overview. That's nice. I mean, I think the door detection, obviously a very useful in the moment tool for navigating spaces. And I think VoiceOver and screen reader has come a long way over the past few years in helping folks to navigate dimensional space, right? To a greater degree, rather than just, I think a lot of people would associate it, for instance, with things on the page or on a flat screen, but instead utilizing the camera and LiDAR and all of the different ML work that Apple has done. Now dimensional space is more accessible. And that was one of the driving goals of this, right?
Yeah, I think you hit the nail on the head. I think the really magical thing about accessibility at Apple is because we build our own hardware and our own software, and because all our machine learning algorithms work on device, we're able to combine those elements to help our users with disabilities solve really difficult problems in their everyday life. And I think door detection, like you said, is combining input from the camera, from the LiDAR scanner, from machine learning, and it's keeping all that information on your device. It's not being sent to any servers. Your data is private and secure on your iPhone and iPad. And at the same time, you're able to kind of go out and figure out the last few feet to your destination without needing sighted assistance. And it's something that we've heard from the community in the past, and we got this problem actually from some users who are blind who are inside Apple, and it was something that we've been trying to solve for a while, and bringing together hardware, software, and machine learning is really the magic formula for us.
Wonderful, thanks. You mentioned inside Apple. I mean, Apple's approach to accessibility, the overall approach to accessibility, I think is a unique one. And that's, how would you describe Apple's approach to making accessible features available to users as different from other tech companies?
I think at Apple, accessibility is a fundamental human right. As a company, we've identified a set of core values that back every single thing we do, every single thing we build, and the way that we work. And accessibility is one of our core values. And when it comes to our software platforms, we're really adamant that accessibility is not something you download. It's not something you buy a license for. it is built into every Apple product from the get-go so that a user with a disability can unbox their Apple product and set it up independently, just like anybody else. And I think the thing that really sets us apart in many ways is that there are engineers at Apple, there are designers at Apple, there are people on our accessibility team who are building these accessibility features, and they are using these accessibility features every single day. And so we're getting feedback from the community, from our users outside Apple, but we're also kind of benefiting from the empathy and the lived experience on the accessibility team itself. And all of that is powering the innovation that you see across our accessibility features.
Yeah, thanks. And go ahead, Dean. No, it's all right.
It's really true. As someone who's been a part of that team in developing some of the access technologies within our applications and our products, just being in the meetings with other engineers and having the back and forth between how to design a specific feature or how to enhance a specific feature is really sort of the proof. When you have those kinds of discussions, the back and forth, you really refine and make the product a lot better for our users.
Mm-hmm. Yeah, that makes sense. And Dean, I'll throw to you since you're already here. I'm curious if you wouldn't mind, give an audience that may not have used it before a little bit of an overview about how VoiceOver works, about the screen reader, kind of what its basic functions are, because it'll kind of set the scene for our next part of our discussion.
Yeah. So VoiceOver is our award-winning screen reader. It is built in all of our devices. And the way it works, sort of a general top level, it examines elements that appear as UI on the screen and presents that information to the user in a succinct way through speech output. Now, typical screen readers, you can navigate and it will speak the element. Sometimes, though, if a developer has not properly made an element accessible, VoiceOver has built-in intelligence technology now, which can actually determine what that element should be and then read labels for that element so that you don't miss out on things that, a sighted person can see. And so we're really proud of that. And the fact that it's built into everything, as Ariba said, it makes it very, very liberating for a person who is visually impaired or blind, because I don't need to think about extra costs. I don't need to think about downloading anything. I can open my product and start using it immediately. And that's something that, as long as I've been here, it's never gotten old, that I can go down to an Apple store and literally use every Apple product in that store. That's just amazing to me still. So that's something that we really pride ourselves on. And it's just kind of how we do. Apple is, it's easy to use, it behaves like it should. And that's where we stand in terms of accessibility as well.
And, Dean, you've been at Apple for something like 20 years, and correct me if I'm wrong, but you've been here since the earliest days of VoiceOver for sure. And I'd love to kind of hear you talk a little bit about the genesis of it. Where did that come from? Where did that initiative begin?
Wow, yeah, it's not quite 20 years, but vastly approaching. Yeah, when I started in 2006, came on as a QA engineer, and there were a few programs, applications that I had to use, things like mail and calendar, and they were accessible. But as I started to, perform my task and had to do things, certain efficiency, I started to make recommendations on how we could improve that experience so that people could work, or at least I could work in a more effective way. And I'll give you a small example of that. When you create a new message in mail, you would expect to go to the to field. Well, we would go to the toolbar. And so I told engineers, hey guys, it would be way faster for me if I just went right to the to button and start typing as a recipient. And that's small, right? That's detail inside, but it's powerful in terms of just the efficiency. So we continue down that path.
Right.
through other apps, and even started reaching out further and making really good, powerful accessibility changes. And in 2008, I don't know how many people remember this, but we introduced speech output on an iPod. And it was the first one we did on a mobile device.
Mhm.
And we also made iTunes accessible. And that was huge. I mean, that was a game changer. Fast forward a little bit more, in 2009, Phil Schiller was introducing the 3GS iPhone, and he sort of slipped in there that, yeah, well, it will be accessible. You know, people will be able to use it with disabilities. And I can tell you that friends that I knew that were blind or and other people just found that confusing. Like, how is that going to work?
I mean, the lack of physical controls, which obviously was talked about in the larger context, because BlackBerry is like, how could you do it without a physical keyboard?
Yeah.
But for a user who's blind, that added a whole other connotation. Like, how will we type on this screen where we cannot touch these buttons?
Exactly. And what's interesting, though, is, we announced it, but it wasn't public yet. So I knew, because I've been testing it for a few years now, a couple of years, and I just couldn't say anything like, well, it was kind of weird. But
so he previewed it during the keynote. You kind of had to hold your tongue for a bit.
Yeah, exactly. But history showed that it actually is very popular, and it turned out to be a very, very good solution. And according to the WebAIMS page survey, that 72% of blind users use VoiceOver, and that's amazing.
Mm-hmm. Yeah, that's fantastic. Thank you for that overview. I mean, I think that the two field is something that we can all appreciate. So thank you for that suggestion. I think that's a default industry behavior now.
Yeah, it's a little inside baseball.
Yeah, it's good. And then, I think ML and machine learning has been one of the biggest boons overall to the work of accessibility as a problem-solving element of accessibility. AI and general AI is a whole other bag, and it's not a panacea. We all know that. But ML specifically, as a tool, has been great for solving accessibility problems. And so I just want to talk a little bit about that, kind of some specific hurdles that ML helped jump, especially as the co-processors and hardware became more available on iOS devices to support these skill sets or tool sets and learning models.
Yeah, I think machine learning has been a really critical tool and continues to be a really critical tool for us to solve problems that are difficult to solve and support our users with disabilities. And it's especially powerful when you consider that our incredible chips let us do this in a privacy-preserving way. And there's a great synergy between our on-device machine learning and the sensors in our hardware and our existing software tools. And so we've talked about door detection, which is combining input from the camera, from the LiDAR scanner, from the on-device machine learning that's happening on your iPhone and iPad. And it's giving you this information about, this is how far you're standing from the door. This is what the label on the door reads. It's, assigned to your favorite new restaurant on the block, and it's an accessible, wheelchair accessible entrance. And all of that information that's being given to the user under the hood, we're using our hardware sensors, our software tools, our on-device machine learning to deliver that. And that's just, one example. Dean just talked about screen recognition for voiceover and how that draws upon machine learning to try to distinguish any unlabeled images and any unlabeled UI. We know that there are third-party apps that may have some buttons that are not labeled, or you might get a photograph from a family member and they've forgotten to add alt text. And in those moments, we're using on-device machine learning to parse that element and describe it to you. And there are countless other examples of machine learning across accessibility. Those examples, of course, you'll find them in vision accessibility. You'll also find them in our live captions for deaf, hard of hearing, and deafblind users. You'll find those examples in voice control for users with acute physical motor disabilities. it's really a critical tool for all of our cutting edge accessibility tools today.
Yeah, and I think that the broader consumer, one of the overarching themes that I've found through my years of kind of exploring and trying to understand accessibility work is that I think the broader consumer doesn't realize just how much they benefit from this work. The long tail that goes into providing the most accessible experience for any user has actually a pretty profound effect on their user experience as well. Like one example being the categorization and analysis of photos to present text in them and selectable text. I use selectable text so much in my photos, whether it's, copying out a label from something and pasting it into a search bar, or even searching for a particular subject like dogs or cats or grass or trees or landscape. And a lot of that work began with the idea of how do we help, a person who is blind to see what is available in their photo archive through the power of ML.
Yeah, I think there are always examples of accessibility paving the way for innovation in all sorts of spaces. And I think your example of live text is a great one. Now, live text is drawing upon on-device machine learning, and it's super handy for all users. But when you are a blind or low vision user and you're able to select text in a photo and then use an accessibility tool such as speak selection or voiceover to hear that text be spoken out loud, now that is a whole different level of access that is made possible by the combination of our hardware, our software, and our machine learning. And there are times, Matthew, when we build an accessibility tool and it gains momentum across different spheres of users. I think if you're familiar with Backtap, that's a feature that we built for accessibility users who—
describe Backtap really quickly for people who aren't familiar with it. I love this.
Yeah. No, so Backtap is a handy feature. What it does is, if you want to set up a shortcut, so you're someone who uses their flashlight a lot, or you're someone who takes screenshots a lot, or you want to launch a specific app really quickly, you can actually customize Backtap, which you can find in your accessibility settings, so that anytime you double tap the back of your iPhone or you triple tap it, it performs that action that you've selected. And so we built that originally for our users with physical and motor disabilities. And we said, we know that somebody with a physical and motor disability might have trouble taking a screenshot and making the right claw shape with their fingers. And what if it was as simple as just tapping the back of the device a couple of times lightly? And that is a great example, actually, of hardware sensors and on-device machine learning kind of all coming together to power that feature. And we've seen it be really popular amongst able-bodied users, amongst users with disabilities, and there are always kind of nice surprises there. That said, I think our focus remains on users with disabilities. Our accessibility tools sometimes have utility for all users, but we're always honed in on the users that are otherwise gated from our amazing products and trying to address those barriers.
And Dean, obviously the advent of ML, you have the historical context to kind of see how that has changed the game in accessibility. Would you view that as like a big cliff for availability of building these new features out?
Oh yeah, I mean, technology in general. I mean, we live in a very exciting time, and watching Apple improve on our hardware and advance in our software, and our accessibility team just right there with it, just trying to take advantage of every leap and bound that we make here. And ML is a big piece of that. I don't see this going away soon at all. I think it's going to continue bringing rich content to people and other things. So I think this is just a beginning of something that's going to be pretty fantastic.
Thanks. And we've talked a lot about first-party efforts within Apple to build accessibility into their products, but I want to talk a little bit about third-party stuff, because you can't, you can't do it all, and Apple's availability or ability to kind of touch all of the surfaces of accessibility is limited in some way. So like, hey, these are the products that we make, and other people make other products for other communities, especially specific communities that have an intense passion around things like gaming and design and other things like that. And so I'd love to talk a little bit about kind of third-party support and how Apple's accessibility efforts integrate with kind of the broader world of accessibility efforts.
Yeah, I'm really glad you asked, because our developer community is so important to us, and it's so critical to the Apple experience that we want for our users. And we know that our developers are always innovating. They're always building amazing apps, and we want to make it super easy for these apps to be accessible to our users with disabilities. And so we're always building accessibility tools for developers, and the newest in that long list of tools is our Unity plugin. So we know that Unity is a really popular platform for game developers today, for graphics experts today. And what we wanted to do was make it super easy for these developers to utilize Apple frameworks, including our accessibility framework, our haptics framework, our game controller frameworks. And so what we did is we put in a lot of work, and we created this plugin that you can download from Apple's GitHub. And you have a quick start guide that you run,
Right.
and within minutes, your Unity game is accessible to users with disabilities using our built-in accessibility features like voiceover and voice control and switch control. And it was really a Herculean effort for the team, but what we wanted to do was put in the work on our end to make it easy for our developers to make their apps more accessible. And that's been a years-long effort. Of course, if you're not using Unity, if you're using Swift UI, AppKit, UIKit, one of our Apple frameworks to develop your app, we make every default element accessible just by design. And so that you have to do almost no additional effort for the app to be accessible if you're using those default elements. And there's a host of tools such as the Accessibility Inspector that's built into Xcode, which is our development environment on macOS, so that if you are using custom UI, it's super easy to audit it and understand whether it's accessible and what you can do to make it even more accessible.
Excellent. Thank you.
Yeah.
I think I'd love to take a couple of minutes to talk about what you're kind of most excited about the future of accessibility. I think Apple is at the forefront of a lot of this work, makes a very, public and concerted effort to ensure that people view their work as central. And I think that is borne out by the products. And as Dean mentioned, how many people do use them. So I think people would be interested to hear from each of you. What are you most excited about in the accessibility work ahead?
I'll start off. I think what I'm most excited about is really our users. As I said earlier, to watch engineering grab hold of some of these technologies and really bring it home to our users is what excites me. And all the time I'm hearing from people who will say, hey, I didn't know this feature was in here. And it's not like, yeah, it was a cool feature I found out. It's like, no, this actually impacted me. This had something to do to improve my life. So that's where I go, without being very specific about what we're going to do next, but it's how Apple approaches challenges of just grabbing the technology and seeing how we can make it work effectively for folks. That's what's most exciting to me about the future.
Yeah,
Thanks, Dean.
I really think that Dean hit the nail right on the head. And I think what excites me the most is going into work and meeting with our incredible accessibility team and getting feedback from all our users with disabilities and trying to understand what is one more experience that we can make even more accessible. What is, any existing barrier that exists, even for a single user with disability around the world, that we can take down today using our technology. And if you're familiar with emergency SOS via satellite, this year we added the option to use your iPhone to text emergency services via satellite connection when you don't have cellular and Wi-Fi coverage. And the team realized that the user might need to turn left or right, to avoid a blocked
Mhm.
signal, and the iPhone is providing visual guidance. And what we did was we were in the details, and we realized that, hey, if a voiceover user is using this feature, they might not get to follow along as easily with the visual signal. And so we're giving the voiceover users sound and haptics feedback to help them avoid that blocked signal. And just that level of detail and trying to kind of work hard to make every single experience across our devices accessible to more and more users. I think that's what, really excites folks like Dean and myself.
That's great. Thank you so much. I appreciate that example, as I do feel that there is a tendency when launching new technologies to say, hey, we're going to launch it. It needs to ship in Q4, needs to affect our business outcomes to a certain degree. We need to launch a new marquee feature, and accessibility is often relegated to near the end of that list, maybe down with quality assurance too. But I think that, viewing it as a priority and saying, hey, this is a very new feature. It's brand new. It's implementing a bunch of new technology and a lot of effort across all of our organizations. Accessibility needs to be woven into that from the beginning. I think that's a beautiful stance, and I hope it does. I hope it's infectious, right? We deal a lot in startups in our universe, and I hope they take that kind of example with them and build these efforts in from the ground up as well. Right along with innovation, right along with shipping their product, they need to understand that these efforts will bear fruit long term. So thank you both for the discussion. I really appreciate it, and thanks for taking the time.
Absolutely. Thanks for having us.
For the next two sessions, we're going to meet two tech founders who are paving the way. You could kind of say they're like Indiana Jones and the Raiders of the Lost Ark, as they're being chased down by a giant boulder, but they're going to beat that boulder and do some incredible things. First up is Celeste. They've developed an incredibly affordable pair of smart glasses that packs a lot of tech punch into them. They're currently not available on the market, but they'll be available soon. Moderating this session is Jennison Asuncion. He is the head of accessibility at LinkedIn and a general leader in the assistive technology tech space. Take it away, Jennison.
Hands-on with Celeste. Moderator Jennison Asuncion. Speakers Shubh Mittal and Smit Patel.
Thanks and welcome. I'm really excited about this particular session because I'm originally from Canada, and this invention is a Canadian invention, and we're going to get into it with the co-inventors or co-founders of the Celeste glasses, Shubh Mittal and Smit Patel. So let's start with you, Shubh, and why don't you tell us a bit about yourself and your story to getting to where we are with the Celeste glasses.
Yeah, thanks, Jensen. It's great to be here today at SciTech Global. My background is in computer science, and before starting at Celeste, I worked at companies like Deloitte and Amazon. I initially got into this space because I was really interested in the smart glasses technology, and I did a lot of research in the industry and basically came to the conclusion that a lot of smart glasses on the market just weren't useful to people. So I was thinking of ways that you can make smart glasses that would actually be useful. And I thought, okay, maybe this is something that can help people with vision loss. And so I called a friend of mine in Victoria who's blind, and I talked to him about his challenges and his life and about the idea. And he just gave me really good feedback. And so I just kept talking to more and more people with vision loss and continued to get really great feedback on the idea. And I thought, okay, maybe this is something that's worth bringing to life. And what's really cool is that the first friend I called in Victoria also studied computer science, and we kept talking about how to make this technology work and actually develop these classes. And I'm really proud to say now that he's the CTO at Celeste, and his name is Smit.
Great lead-in, Smit. Why don't you tell us a little bit about yourself and what was the passion for you to get involved with this project?
Mentioned, I studied computer science at University of Victoria. Actually, I was the first blind student to study computer science at UVic. So one of the biggest challenges with me being in a new place, like if I was studying at UVic, so I moved to a new city, and one of the challenges was finding different things, grocery stores, getting around the campus. And so one of the biggest challenge for me was uh, with that is using your phone. Sometimes I get on a FaceTime call and it's difficult to point my camera, and with holding a cane, then essentially my hands are occupied and I cannot do much. So the idea he brought up when he brought up the smart glasses with me, it was a really interesting idea, and I really liked the fact that it would give me more hands-free experience and more freedom to move around and just make things very easier for me.
I got to tell you, Smith, that's one of the reasons I got excited about this when Ned Desmond first approached me to participate in SciTech Global. Was I had seen a couple of wearables out there in the market over the years, and it was a little hesitant because they're typically the ones I've seen are big and bulky, and they don't allow me to use my cane, and just using the cane and the phone, like you said, can be a little cumbersome. And I mean, I'm holding the glasses in my hand right now, and I can tell you, as someone who's blind, they feel sleek, they're lightweight, and there's nothing about them that feels that much different than a quote unquote regular pair of glasses. The lenses are a little thicker, but nothing that would prevent me certainly from trying them out. So I like where you folks went with the design and the architecture of the glasses. Shub, you kind of alluded to this a little, but I wanted to see if you wanted to say more. There have been a number of wearables that have come out there for the blind and visually impaired market over the years, and I'm just wondering, like, what made you decide on the glasses? How do you feel these differentiate themselves in what's available out there now?
Yeah, a great question. I mean, it's exactly like you said, like when we started off, we were looking into the assistive technology industry, and a lot of the products were bulky, they were hard to use, and they were incredibly, incredibly expensive. I mean, every single person that we talked to had a scenario where they wanted to buy a piece of assistive technology, but didn't because of how expensive it was. I actually talked to the sales director at one of these big assistive tech companies about the price of their products and how they expect people to pay for the product, because he knew the unemployment numbers, right? Like he knows that there are a lot of people out there with vision loss that struggle with finding jobs. And what he said was that they're mainly targeting people that are retired and have a ton of money, or people that are covered by huge government grants. And that's crazy because that's such a small percentage of the visually impaired community. Right? Like most people aren't covered by government grants, and most don't have a ton of money lying around. And oftentimes it's those people that need access to this technology the most. So our mission is to change that narrative that assistive technology has to be bulky and expensive. And our goal is to revolutionize the smart glasses industry.
That's awesome. And we'll get into a little bit later in the next question after the next one I have for you folks about the audiences that you folks envision. But let's get to the neat stuff. Smit, in terms of the glasses themselves and the technology that's in them, either you, Smit, or Shub, what differentiates these glasses technologically from others that might be out there on the market? that you want to comment on?
Okay, for sure. Yeah. So, as you and Shub were having the conversation about it, firstly, our glasses are much slicker. They have a really great form factor. They are really indistinguishable from a regular pair of glasses. Yeah. So the glasses have a autofocus camera. Then we are the first company to have a dual bone conducting speaker system on our
I
glasses.
love that. I love that, by the way. The sound, yeah,
Yeah.
that sound is amazing. Sorry, keep going, keep going.
Thank you.
Thanks.
Yeah. So that's one of our differentiating factors, and we have a microphone, obviously, and mostly the other companies, wearable devices, they do AI features such as OCR, object recognition, etc. We have those features. On top of it, we also do video calling, like a user who is a blind person or a partially sighted, visually impaired person can call a Celeste volunteer or a person in their family, friend, peer network, and basically they can get help through a video call through the glasses. And we also, as I was previously just mentioned, I can expand. The user can read text, recognize objects, get scene descriptions, and other AI features through our glasses.
That's amazing. Shub, did you want to add anything else?
Yeah, well, I mean, also about, I'm holding the glasses in my hands as well, and yeah, we have all of these amazing AI and video calling, and the glasses weigh 55 grams.
Yes, these are very like, I'm also holding my set here I'm here in the Silicon Valley. You're out in Vancouver, and see, we both have our glasses here. I have to say that the one thing I found interesting was that you built in gestures into the glasses themselves. So I could flick up for the volume and flick forward to run the to take the picture. Now, in the interest of full disclosure, and we'll talk about this again in a subsequent question, but there's a mobile app that goes along with the glasses. But I'm just wondering, is it possible right now to remap the gestures? So if I wanted the flick forward feature to do something other than take a photo, is that possible yet, or is that something that I could put in as a feature request?
Yeah, no, that's absolutely something we're working on. We haven't exactly figured out the exact integrations, like what button does what, and what a swipe should do what feature. That's something like right now we're testing the glasses, and so we're gonna change what that maps to as we test it, and then yeah, ideally we can also give that to the user, because some people might really like the AI features and say they don't want to map the buttons to AI. Whereas other people really want to call, and they might want to call certain people every time. And so allowing people to create like custom mappings on the glasses will really help. So yeah, it's something we're working on.
Amazing. Let's switch focus for a minute. We kind of alluded to this a little bit before, but and I'll let you two decide who wants to take a first crack at this question. But who are the different groups of blind or visually impaired users that you envision would be using these Celeste glasses?
Yeah, well, I mean, firstly, we have just the people that have pre-ordered the glasses so far. We have lawyers and artists and students and software developers and Paralympic athletes and so much more. And so we have a lot of features that are just helpful for everyone, right? Like being able to read text is a challenge, whether you're in school, you're retired, and being able to video call is helpful for everyone. But that being said, we think there's a lot of use cases specifically to help visually impaired people in school and in the workplace.
Oh, I absolutely. I know, Smit, you were talking in your introduction about just getting around Victoria and getting around a new place. I could totally see these glasses being helpful for someone who's going for a job interview. And it's nerve-wracking enough, and it's not like you could have an opportunity to kind of get orientation and mobility to a brand new location on demand, but to have the glasses and whether it's a friend or family member or another service provide guidance and with the autofocus camera and just not having to worry about lugging a big heavy device around to help you with directionality. I could totally see that as being helpful. So I think that employment situation is neat, which is kind of ironic given Shub, you mentioned that the person you talked to in the assistive technology industry was talking about retired people who had lots of money. And here we are, we're trying to get people jobs, right? So, and I also think in the campus environment, I remember having to learn a campus. I would go with a friend ahead of time to just learn where classrooms were. I'm completely blind myself, but sometimes classrooms change at the 11th hour, and it's just nice to know that that this is available. And similarly, in an office situation, you could have to change a conference room location sometimes. So, but I'll stop there. I don't know, Smith, did you want to add anything further about the different groups that you hope will take advantage of these classes?
For sure, yeah. I'll just add, there are so many different opportunities for different peoples in lots of professions that they can use the classes, or even imagine at your house when we get a new product and trying to figure out how to use the product. That's also very interesting use case. Or there can get help while cooking. We already touched on navigation, etc. So these are some of the use cases that I was thinking. And as one other thing as well, we just want to provide more independence to the users. So yeah, that's what the glasses would be able to do.
No, that's great.
Yeah, exactly. I mean, like going back to the example of school, like right now, a lot of students need to have someone beside them that's helping them like take notes from the board or helping them kind of use like inaccessible physical worksheets they have to do. So with the glasses, you can kind of do that stuff yourself. You can read the board yourself, you can read worksheets yourself. Same with the workplace. There's all of these documents, I'm sure, as you know, Jensen.
Yeah, and not only documents, but I remember the days when I was in the classroom and, like you said, professor put something up on the display, but in the corporate environment, during training courses, people put up PowerPoints, and not only that, like if I want to go to a live cultural event, like a concert or a play or something like that, there's built-in audio description by, if I'm wearing the glasses, I'm assuming I can just keep the volume low enough to not disturb others, but to still get information, which is great. I alluded also earlier to the fact that because this is all cutting edge, and you folks were good enough to be able to ship me glasses so I could at least see the glasses. I know you're finalizing the mobile apps. There's an iOS and an Android mobile app to go with these glasses. Shub, I'm wondering if you wanted to take a first crack and just talk to folks tuned in as to how does the mobile app work with the glasses?
Yeah, absolutely. So when you're using the glasses, you'll have to download our app, which, as you said, is on iOS and Android. And it's essentially through this app that enables all of the functionality that we've talked about so far. Like when you open the app, you'll see a list of the contacts that you've added that you can click on, and it'll start a call with them through the glasses. Through the app, you can choose a volunteer, you can choose one of the AI features. Right now, it's all controlled through the app, but as you said, like we're adding other ways to interact with the device, because the whole point is that it's hands-free, right? And so right now it's through the app, but we want to add ways that you can use voice commands to the glasses, or
Oh, wow.
use buttons on the glasses like you've tested,
Yes.
or even like in real life gestures, right? Like what if you could just point at something, like you're holding a piece of paper and you point at it and it's able to read it out to you. And so a lot of these cool features is what we're working on, so you don't necessarily have to use the app every time. But yeah, so the way it works with the app, the reason you need it is because you need to connect the glasses to your phone's hotspot. And this also means that you can use the glasses wherever you go. You're not tied down to only at home with Wi-Fi. Uh, you initially set up the glasses, and after you do that, they'll just automatically connect to your phone's hotspot and your phone's Bluetooth, so you don't need to set that up every time. And yeah, and they'll allow you to control all the features. You can also use the glasses as just Bluetooth headphones. So all of your audio, like music and voiceover, can go through the glasses. I mean, I use the glasses just on like my bus ride home, just to like open up Spotify and listen to music. You can pick up calls through the glasses, and those kind of things you can do without the app.
Neat. No, I think that's great that there is functionality with and without the mobile device, and I look forward to trying out the mobile device and pairing them with the glasses. Smit, was there any other functionality in the mobile apps that Shub may have missed, or do we have good coverage there?
I think, yeah, we have pretty good coverage. Yeah.
Okay.
With that.
Smit, why don't I, for this last question, why don't I start with you? What does the future of the Celeste glasses look like? And most importantly, for folks tuned in, when can they get hold of a pair of the glasses and try out the mobile app as well?
For sure, yeah. So let's talk a little about the future first, and we can talk about how, yeah, folks can get the glasses.
Absolutely.
So for our future, we, as Shub touched on it initially a little bit, we want to change how people interact with technology. What I mean by that is, right now, if we want to use a piece of technology, then we have to either pull out our phone or a laptop, and we have to exactly give it a command or tell it what we need it to do, right? But what we want to do is, as Shub said, like maybe it could be a light gesture, can be as simple as pointing at a box, and the glass is recognizing that, and it easily reading the content or from the box. So that's one thing. As I was previously touched on a little bit, we want to make the user more independent and provide them with more feature freedom. So we are actually planning to add navigation and explore features on our glasses. The glasses would be able to give turn-by-turn directions to a user. Let's say if I was exploring a new city and I'm walking down a street near my hotel, so the glasses would be able to tell me if I pass a pizza place or a store, etc. We also want to add indoor navigation. And what I mean is, if, yeah, we touched a little bit, you and me, like if when we were at school, we had to go to the campus earlier and know where the classes are. At work, we need to know where the conferences rooms are. And with the indoor navigation, the glasses would be able to give us accurate directions even inside a building as well. And yeah, we know we have lots of AI features and video calling, but all of them use data. So if user is worried they might be low on data or be in an area with not good network connection, then we are also making offline AI for those use cases. So users would still be able to read text, recognize objects through our offline AI features. We also want to, yeah, to add more, we also want to integrate with more of our favorite assistive apps like Good Maps, Soundscape, Seeing AI, or yeah, there are lots of great assistive apps, and we want to integrate with them on our platform as well.
Perfect.
Yeah,
I'll just add one thing to that, which is, we're working on all of these great features for the next coming months. But what's really cool about what we're doing, and again, we're talking about the role of the mobile app, is all these features won't require a new set of glasses, right? It won't be version 2.2, 2.0, 3.0 that, okay, now you can have navigation. What it'll really be like is just an update on the App Store. And so it's just all of these features are available for free, and it'll just be available to you when you update the app. So you don't need to go get new hardware every time. You'll just always have access to the latest features that we develop.
Great. And Shub, did you want to comment on, is it too early to give a solid date on which folks who are tuned in might be able to try the glasses themselves? Are we talking months, 6 months, or is it still too soon?
No, yeah. So where we are right now with development, and actually, Smith, maybe you can answer this.
Yeah, absolutely. Right now, we are actually delivering the glasses to our early pre-orders in next 2 weeks, and we will be slowly flushing out the product and developing new features, as I mentioned. And users can expect to get the new glasses sometime mid next year, might be early April or June. And yeah, so right now
Great.
we are just doing, users can book their glasses by paying $50 for now. And yeah.
So just because you cracked out a little bit there, you said $50?
Yeah.
That's
So
great.
essentially how it works is, like I said, we're going to release, like we're getting feedback from users and we're going to kind of polish the product and make improvements based on that feedback. And then we'll release the glasses in the summer and they'll cost $950. But like the way we did it last time is we had, unfortunately, just a limited quantity that we could sell. And so moving forward, we'll have more glasses, but we still predict they'll be limited. And so if people are interested, they can just go to our website, which is celeste.co, celeste.este.co. And on our website, there'll be a checkout form where you can pay $50 and put down a deposit for the glasses so that when they come out, you'll get a discount on the glasses and you'll kind of reserve your spot for when we fully release them.
Wow, this is amazing stuff. I want to thank Shub and Smit for taking time and for joining me here at SiteTech Global to discuss the Celeste glasses. I'm looking forward to, I just moved to a new city, so I'm looking forward to trying out some of these new features as they're rolled out. So thank you very much for your time and good luck.
Thanks, Jenison. It was great talking. Yeah.
Thanks, Jenison, and thanks, SiteTech, for calling us on. It was great to be here.
Thank you, Shub, Smith, and Jenison. That was a very interesting session about the Celeste glasses. I really can't wait to get my hand on a pair of these, as it seems like a really slick James Bond type of a way to invoke the Be My Eyes app without taking your phone out of your pocket. Our next session is ARX, which is kind of like Celeste because you wear them on your head, but these are not glasses. This is the founder's journey to build a product for people who are blind. The session is moderated by Lucy Greco, head of accessible technology at Berkeley. Over to you, Lucy.
Hands-on with ARX. Moderator Lucy Greco. Speaker Charles Leclerc.
Thank you for that introduction. It's really nice to be here at Site Global, and I am very excited today to be interviewing Charles Leclerc from ARC, and he is the co-founder of the company. And Charles, I'd like you to tell us a little bit about yourself.
Hi, Lucy. Thank you so much for this opportunity. It's such an honor to be here at SiteTech Global. So yes, my name is Charles Leclerc. I'm the CEO and co-founder of ARX Vision. And yeah, it's a pleasure to be here.
Excellent. Charles, can we get started with you telling us a little bit about why you actually founded ARC Vision? What is it about? Why did you do this?
So my background is actually in video games. I used to work at Ubisoft in research and development, where I worked on a lot of motion-based sensors like the Kinect and the Wii U. And then I worked on blockbuster franchises like Assassin's Creed and Prince of Persia. And I thought, in video games, we use lots of cutting-edge technologies and lots of good design thinking. What if we took all that knowledge and brought it to products that are looking to solve real-life problems? And so that took me onto a long journey of going back to school at the RCN Imperial College to study innovation, design, engineering. And, to make this short, I ended up working at the BBC at the Future Experience Technology in London. And I was leading the team discovering the potential of augmented reality as a public service. And one of the prototypes we built was an audio AR experience that allowed you to place audio stories in your environment and to curate your environment with audio. And I thought, okay, who needs this the most? And I was in touch with the company formerly called Horus Sight, and they've hired me as their CEO, and we rebooted this company into ARX Vision, with the vision, obviously, to augment reality with audio for the blind and visually impaired.
Excellent. So that's an amazing background. And I thought I detected some Quebecois in that accent. So from Ubisoft, it's fascinating to me how much the game industry is actually leading in accessibility. And the fact that you're coming from the game industry with an innovation for accessibility, just proves that point. So I have with me one of your headsets, and I want to explore this. So this is built on a bone conducting headset, which I really like the idea of being able to keep my ears clear when I'm walking around my environments. And it has a camera up front. And when I read through the literature, it said that there's 2 cameras actually in this box. Is that correct?
Yeah, that's correct.
And what you've done is you've made some really good tactile controls. One of my big gripes with the world nowadays is that there's not enough tactile controls. Things can't be felt. And these are really well feelable buttons, and they're all shaped and have whenever you talk about them in your literature and in your tutorials, you actually talk about the shape of the button, I really like that. And then you also have a volume control on this side, which is very, very tactile as well. So nicely done on the, infrastructure of it. I'm just going to put the headset on and show people how I would look with it on. So it fits over my ears really nicely, and I have a badly shaped head for these things, I have to tell you. So you'll see it slips on me a bit, but that's because I don't have it fitted properly right now. So it sits on my bone in front of my ear, and then the camera is next to my face. I have one comment for you in that while I was playing with this the other day, it got very warm, and this very warm device next to my cheek was a little uncomfortable. But otherwise, the camera can move up and down. So if I'm looking for, say, something I dropped on the floor, I could point down somewhat and not have to tilt my head too much, or have it point straight ahead of me as I'm walking around to try and get my environment. The system you've developed with the echolocation sound moving back and forth is interesting. I'm wondering if that's just telling a person that the device is actually active, and if that sound could be turned off. Is that possible?
That's a very good question. So first on the the audio, yes, the first purpose of so I wear the headset as well. Here we go.
Yep.
So what's happening is that the first purpose of the sound you hear and you mentioned is to let the user know that the camera is running. But you would have noticed that it goes from left to right.
Yes.
And that is to actually make you aware of the stereo ability of the headset. And
Perfect.
So when you, for example, detect an object like your hand or a document, it's basically designed to make it feel like you hear the audio coming from the object. And that's going to be incredibly useful in the case of searching for objects and things like this, because you can just rely on the echolocation.
Narrowing in on it. I like that. I like that a lot. So let's get to the purpose of our chat today, which is where what we really want to talk about is, this great product, but mostly what we would talk about is your process of creating the product. Tell us, how that whole process went. Was it a lot of experimentation? Did everything turn out the way you wanted it? Tell us a little bit about, the journey to getting an actual finished product?
I'd love to do this, and it's been an incredible journey, and that journey has actually been enabled by the community. So whoever's watching, who's been involved in the process, the entire ARX team, thank you. So basically, when I joined ARX, the headset was nearly done, but it was there was no app for it. And so what we decided to do is, obviously, we designed the headset to be specifically for blind people. So that's why you have all these physical touch buttons, so that you can, know what you're doing with just the sense of touch, and that's useful for sighted as well as non-sighted people. Obviously, the product doesn't cover the face, so these are all the things we learned from users and what people wanted, and that's really the key to this process. I think one key feature is the bone conduction. Obviously, this is incredibly useful because earbuds would isolate a person. So if you're isolated, you can't hear your surroundings properly. But if you have a loudspeaker, then everybody can hear the AI, and that's not really nice in terms of privacy or being in public environments. And so in terms of the software, really what we wanted to do was to fail early and learn. So we didn't try to create a product in a lab and make it perfect. We were like, okay, let's get it as soon as possible in people's hand, and let's see if it crashes or if it survives. And so what we did is that we took the headset, we made an app, and the app at the beginning was a clone to Microsoft Seeing AI or Envision AI, because we didn't want to make anything new. We just wanted to build what people would expect. And so from there, we launched our first version of our product that was nearly 2 years ago. And it was awful. It just didn't work. I mean, the software worked, but the interface didn't work, because what we had done is that we based everything on the graphical user interface model. So you still obviously could use your voice and the buttons of the headset, but you had to interact with menus that were nested in other menus. And so because you couldn't see them, you had to imagine this whole map of menus. And so we took our learnings from that experience, and we went back to the drawing board, and we redesigned everything. And we actually came up with a conversational interface, something similar to what you have with AI assistant like Alexa or Siri. And then we started that process of having beta testers being involved, and we kept pushing updates. But I would say that the voice user interface was really the big breakthrough that enabled us to start that loop. And we've basically kept learning from people, and we actually keep doing so. Even if feedback is good today, we're looking for how we can make this as perfect as possible.
That's actually really, really important. That the idea that you use there, that you built it to fail, and then failing was how you learned. Once you brought blind people in, did you have anything that was challenging, that your assumptions were either excellent or really bad? Something happened when you brought real blind people in to start doing your beta testing. Tell us about that experience of working with people.
Yeah, absolutely. It's actually a good opportunity to share that experience. It was not easy. At first, I had no, I had no preconceived idea of how that would work. But what happened is that when we were ready to ship our first units, it was during lockdown, and so I was just unable to meet in person with a user, and. And so what happened?
That happened to a lot of us, didn't it?
Exactly. But how do you start and learn from a physical product when you can't be in person in the room, and you can't even be on Zoom? So what happened is that the first trials were a nightmare, and lots of emails and phone calls to be like, no, you have to press this button. It was complicated. But what we did is that we built, and that is actually coming from my background in gaming, we built an interactive onboarding experience, which takes the user the first time you open the app, you're taken through this audio experience that teaches you how to plug in the headset, how to press the buttons, what they do, the core principles of interaction. And, so through that actual challenge of not being able to meet with people, we came up with, I think, a good solution that is really helpful even today.
I really liked your audio tutorial. It really walked me through quite nicely. I don't remember being told to how to plug in the camera, but that was the, the audio tutorial went through very nicely. It first of all, told me to press a button. It told me which button to press, then explained once I did that, what that button did and how to use it again. And it was a really nice audio onboarding. I really liked that onboarding a lot. It was really quite amazing.
Thank you for saying that.
The one thing I did want to point out to you, because you said you are interested in feedback, is when I plugged the device in for the first time, the sound level was at 0. And I could not hear my phone, and I could not hear the camera. I could not hear anything. So it's got to be something's got to happen there that, I couldn't continue the onboarding until I actually got my husband to help with the volume. Once I hit it on screen, he was able to raise the volume for me. But because I could not hear talk back, I could not raise the volume of the device, even though I tried to use the volume switch on the headset.
And you're touching on a very interesting point. So what's happening in basically being an app and a hardware product, what's happening is that, so we're talking about the Android ecosystem,
yep,
which is really super awesome and has lots of accessibility features that we love. But basically, we don't have as much control as we would like on what happens in the operating system. We have control on what happens within the app. That's like, we can control everything there. But, before you're in the app, that's the challenge. And so this is why we do need to improve on that part. But we created, I don't know if you received it, but there is a QR code on the packaging that takes you to a link with an onboarding audio description.
You brought up 2 points I want to follow up on now. Let me address the QR code. Yes, that was excellent. That worked really, really well. The Braille manual was really lovely as well. Very simple, straightforward. You should get someone to proofread your Braille a little bit, because you change between computer Braille and literary Braille interchangeably. So one time the URL is spelt out in computer Braille, and another time it's not spelt out in computer Braille. It's literary. But it's actually a really nice, durable little manual. It's a very cute little booklet with very solid pages, that the Braille won't rub off on and disappear. So nice job on the manual. But let's get back to your decision to use the Android ecosystem. I am an oddball in the United States in that I actually am an Android user and I prefer the Android ecosystem. But a lot of blind people here really do prefer iOS. Is there a specific reason why you guys chose Android versus iOS? To start with, I understand you're going to work on an iOS product, but what was your motivation to start with Android and then move to iOS?
Yeah, that's a very good question. So being on iOS is definitely on our roadmap. We know that most of the audience is on iOS, so we want to be there. The reason why we chose Android is because it's faster to iterate and to deploy and launch applications. Also, in terms of hardware, it is a little bit more complex to do it for iOS, and also we're unsure about what the situation is going to be in terms of USB-C versus Lightning. It's actually a hot topic right now, and no one knows what's going to happen. Is it going to be one or the other, or maybe none of it?
Yeah, come on, Apple. Let's get with the rest of the world and finally go to USB-C, or at least standardize with everybody else. Don't stop charging us more for your own standard. I agree with you on that. The USB-C versus Lightning. That's that's a key point. I mean, how are you going to get your device to connect? And I see you didn't go with the same, mistake that other people who've tried to do this kind of thing before have done, in that you right off the bat went for a hardwire. You did not try to go for the latency of Bluetooth, which I like.
Yeah, that's actually a very important point, and actually it is a debate because customer expectation is that for any category of customer we want wireless products, but a wireless wearable means that you have to charge it, so you have to remember every day, okay, I need to charge my device. That's that's friction, that's opportunity cost in your everyday life. And then the second point is, if it's wireless, you have to pair the device.
Yeah.
Which is, it doesn't work perfectly still. And in terms of data, with the USB-C 3.1, we have 200 times more bandwidth than with Bluetooth. So we have a lot higher quality images.
Yeah, and I mean, that's really important because the AI is doing that image recognition, and the better the image, the more likely they are to do that recognition, which I find absolutely fascinating that we've come around to that. I mean, I was an early OCR user in the 80s, and when you did OCR, the more data you had, the worse it was. You never went above 300 DPI. Nowadays, to get the better recognition, you actually need to up your resolution. So that's really fascinating. I had one question for you about the actual image recognition. Is that done on the device, or is it all done in the cloud?
So also a very good question. Some of it is done on the device, on the smartphone. None of it is done on the wearable. The wearable is an accessory.
It's a camera. Yeah.
Exactly. Well, there's a bit more going on because of the stereo compression and so on.
Yeah.
But yeah. So yes, we do what we can. When we can do it on device, we do it on device. But sometimes we get much better results using the cloud. And so our vision is, if internet is available, then we'll use the cloud. If the latency is low, we'll use the cloud, because it's just limitless what we can do. But if the internet is not available, if there's no connectivity, we still want our users to be able to use ARX, and so feeders will still be available. I do know that currently our document reader doesn't work offline, but it's only a matter of days and weeks before this is fixed.
I have to say, the number of items that you have on the menu, I never got to the end of it. It's a large list of items a person can look for. And I compare it to the large list of items that's in Lookout. You've got 20 to 30 times more items in your list. I mean, they stop at table, chair, and dinnerware, but you go all the way into cup, plate, table, all sorts of different things in the list. And I never finished it because I was just like, this list is endless. It was wonderful, the amount of items. Do you ever have a dog in there? Can a person look for their dog?
Yeah, that's actually a really good one. So Steve Nutt, who works with us very closely, is always asking me, when can I detect dogs specifically? And so what we want to build ultimately is something that's probably similar to Lookout, but it's a funnel where we're able to detect that it's a dog. And if we know it's a dog, then we're going to load a model that's very good at detecting the race of the dog. And so we want to be able to do this for everything.
I like that. I like it a lot. I think Steve and I are on some of the same listservs, and we're both asking the same questions all the time. Sometimes when I'm out at the park, I'd love to be able to find where my own dog is in the dog park. So
so that's actually a good point. We're working on the ability to learn things, to teach things to ARX. So currently, we have all these modes, like the scene mode, the document scanner mode, the short text. What what you already have in seeing AI and so on.
Mhm.
And where we want to go is to have a modeless experience, or maybe only two modes. The first mode is what we've started to build with the scene mode, where you get scene descriptions and text recognition and face recognition all in one mode, so you don't need to switch modes. And then the other aspect of the user experience is the learning mode. So, you'd be teaching faces, teaching a favorite object, a location, or your dog. And then when you're in the explore mode, you'd be able to detect all that.
Well, you can count on me to beta test that portion. I have a question for you. Are you always going to depend on the camera, or can a person use the camera on their phone? Say, if you're in the kitchen and you wanted to recognize what the can was you were holding, can you just use the phone with the same application, or are you dependent on your camera? And if the answer is no, you have to use the camera, I would say change it.
So the way this works is, if we see that there is demand and a need for this, then the answer is we'll probably do it. So we'll probably open the access to the phone's camera. However, our mission is to really offer a hands-free experience. And the thing I hear every day is from the community is, I don't know where is the text, I don't know where is the QR code, so I have to hold my smartphone in front of me and wave it all around. And that's also true for scanning a barcode on a box of cereal.
Yeah,
And
no, exactly. It's just that I don't want to wear that around the house. If I have to do something in a hurry, I want to be able to, not have to go and get rigged up with the headset and do all the rest of it from there. But no, I think this is a really well done product. I mean, we've had other iterations that do this, and the hands-free is actually key. I think, for moving around and navigating, that's going to be a really interesting experience. And I can't wait to get home and try this on my new phone and see how it works with a better phone model.
I really look forward to having your feedback.
Yeah, I'm excited. This is it's always fun to learn about new products. I really want to kind of get back to the experience of working with people with disabilities, because I can tell you, every time I give a talk or a presentation, I always point out that it's really important to bring in people with disabilities. Do you have any stories that can, express something you learned from some of the people you worked with that you would never have thought of without them?
Yeah, absolutely. I think Steve has been really important in that development journey. And I've visited him a few times, and I actually just observed him in his home, how he is interacting with objects, how he was trying to read documents. And this is, basically, when I was building the first version of the document reader, I was using my eyes to scan documents, and then I was giving it to Steve, and I was like, just put the document here, it's easy, I'll show you. But Steve could, at that point, he just couldn't do it, and that was actually completely fair, and what happened is that I learned from Steve that I shouldn't use my eyes to track the document. And we actually, Steve told me, we need to verbalize everything you use with your vision, so that the blind people can actually do it in the same way. And today, Steve now says that our document reader is the best ever because of that work we've done together.
That's really great to hear. That's absolutely amazing. Yeah, normalizing to a person who is your end customer is something really hard for people to do, even if that person doesn't have a disability. And trying to think of what your customers are doing, the engineer back at the lab has their own mindset, and then not thinking about what the end user, who doesn't have that same knowledge that the engineer does, how to think like them is a really important factor. And normalizing, like you said, so don't use your eyes when you're trying to come up with the steps. I mean, I had this very thing happen yesterday. I was trying to deposit a check with my phone, And normally I just hand it to my husband because, I just don't want to bother with it. But I've got to get some independence. So he sat there with me and watched me do it. And he's like, the instructions it's giving you are absolutely ridiculous. They make no sense. It kept saying, turn document 90 degrees. Well, when I turned it 90 degrees, it still said turn document 90 degrees. And so he's looking at the screen and said, whatever it's trying to tell you has no basis in reality.
Yeah, and we're running out of time, but I would love to speak about this topic we could speak about it for hours, and really, I would emphasize that the community has been so overwhelmingly active with ARX, and that has made a big difference.
Yeah, when you have the community involved, you get a better product. Ultimately, the product becomes what the community needs. If you try and give us something we don't need, we kind of shy away from it, and we end up finding that there's some of the things built into it that just don't work. I just can't emphasize enough how important it is to work with our community, and not just ask them to volunteer to do things for you for free, but pay them, interact with them, make them a part of your project, and give them credit. If you eventually have product credits, I'm pretty sure you'll include Steve's name in those.
Yeah, absolutely. And actually, we've created the ARX Academy, which enables anyone to request a feature. And we want to name those features by the name of people who've suggested them. So if you get ideas, where to look. Go on the ARX Academy.
That's fantastic. Charles, this has been a wonderful conversation. If you had any last words you wanted to say to the community or to other developers like yourself, what would be the one thing that you'd want them to know going forward?
Well, I want them to know that the goal of ARX is to democratize wearables, and that these are the early days, and we need everyone to get involved, because this is the only way we can make a good product that's going to solve the problem for real.
Excellent. Well, thank you very much, Charles. I really appreciate you having this conversation with me, and good luck, and be prepared to get a bug list from me.
Thank you so much, Lucy. It was such a pleasure.
It was a pleasure for me. Thank you.
Thank you, Lucy and Charles. ARX sure does sound amazing. I don't know about the rest of you, but hearing all these panels, my holiday gift list sure is getting a lot longer. I've decided, though, that I'm going to make my Amazon gift list available later in case any of you want to get me a gift. Our next session comes from one of the most experienced and trusted companies out there, Humanware. Humanware recently released the Stellar Trek, and the Stellar Trek is different than ARX and Celeste, as it's not reliant on your phone. Our next moderator is Sam Prue, lead accessibility evangelist over at Fable. Fable is a company that connects people with disabilities with user groups for accessibility testing. Sam has actually been a guest on my podcast, That Real Blind Tech Show. So it's great to see you again, Sam, and I'm excited to hear your conversation all about Stellar Trek. Over to you, Sam.
What's next with Stellar Trek? Moderator Samuel Poole, speakers Luis Philippe Massé and Peter Tusick.
Thanks, Brian. Great to be here at SiteTech for another year. Always an incredible conference with so many incredible panels each year. And this is going to be another one of them with some folks from, a company that has been in the assistive technology business and in the accessibility business for a long, long time. Really incredibly glad to be here with two great folks. First of all, Peter Tusick, Director of Strategic Partnerships at Humanware. Peter, why don't I let you introduce yourself a little bit?
Thank you so much, Sam, and I will second the appreciation to be here. My name is Peter Tusick, as you said, and I am the Director of Strategic Partnerships at Humanware. I am based in Chicago. I am totally blind, and I work with primarily, it's a kind of a tri-faceted sort of role. I work with a team of product specialists who are wonderful and do a lot of in-house sort of support, as well as boots on the ground support for our sales team. I work with product management on kind of being the ears on the ground, if you will, and taking pieces back to our product management team. And then the third piece of what I do is work with our key partners. So whether that be blindness organizations, institutional partners such as the National Library Service, or governments and other entities in various parts of the world. So we think of the CNIB in Canada, or the RNIB and Vision Australia, and other folks around this big old world. So kind of a multifaceted role, but I am absolutely thrilled to be here, and I'm a user of all these pieces of technology we're going to be talking about as well. So thank you so much for having me, and I'm thrilled to be here.
Absolutely. Lot of different hats you got going on at the same time there, because accessibility, doesn't happen alone. We work with a lot of folks to get these things done. And secondly, we're here with Louis-Philippe Massé. I probably got that wrong, even though I have a French name myself.
Excellent. You're good.
Director of Product Innovation, VP of Product
Yeah,
VP of Product Information at Humanware. I apologize. But hey, why don't you introduce yourself? Hopefully doing a better job than I did.
I hope so. It's I have more practice than you, so that's why I can do it. Yes, Louis-Philippe Massé. I'm the VP of Product Innovation here at Humanware. As you guys mentioned, Humanware is gonna celebrate next year its 35th anniversary, so we've been there for a while. My team is the product innovation team is the R&D team. But also the product management team. So that's why Peter and I often work together, of course, but also I'm lucky to have the R&D team under my supervision to make all these great products that we have been releasing in the last few months, but there's way more to come. So of course today we'll focus on one of them, but it's exciting to be at Humanware, and it's exciting to be at this conference again this year.
Absolutely. Speaking of those products and all the great products that Humanware has released over the years, from the Victors, which I have owned and used, to the Treks, the product that you've most recently released is the Stellar Trek. And so for those folks who are maybe coming into this who are a little bit unfamiliar with the Stellar Trek and what it is and what it does, why don't one of you give us a quick overview of that, because I know not everyone keeps at the forefront of all of the new great tech releases going on.
Sounds good, Sam. So at its core, what the Stellar Trek is, and that's the product we've just recently released in August, the very tail end of August of 2022. The Stellar Trek is a navigation device that is specifically designed for somebody who is blind or visually impaired. So that blind and visually impaired traveler, at its core, it is a turn-by-turn directions type of device that will give you information that's pertinent to the blind traveler. So your direction of travel, the address range you're near. Those things are great, but also more in-depth information, such as what intersection am I coming up to? Not just the name of the street, but what type of intersection. Very, very relevant to a blind traveler. It's nice to know if it's a four-way versus a three-way intersection. We listen to traffic patterns differently. So a lot of that info. Additionally, it has some unique devices, some unique features that is on the device that will really kind of bring it to the next level. So we talk about landmarks, being able to drop audio pins, if you will, or breadcrumbs as you travel, and then also the ability to remember routes and kind of gather that type of info. What we've done to kind of amp it up or bring it to the next level is we've introduced artificial intelligence into the product, where we have cameras on the device that will capture information in the traveler's environment. This information at launch is used to identify addresses as well as doors, which we can get into. So again, when you get to that destination, knowing where the address or what address you may be near, or if there is a door present, trying to find that, you can use the cameras for that, as well as pulling text out of your environment. This can be done in quick reading mode, so being able to read information, maybe signage or hours on a window of a business, or you can use it to read full pages of text, the menu when you sit down at the restaurant, or a piece of mail that shows up in your mailbox. So it is still a standalone GPS product, which we have been in this space for the better part for more than 2 decades, 2.5 decades at this point. And it kind of takes that to the next level with some onboard artificial intelligence.
So I know we've got one here with us, and I know the tail end of August with all of the things that have been going back on over the last couple of years and the world just opening up. It's been a tough time to release a new device and a new product, isn't it? And I suspect there's a lot of folks who haven't gotten their hands on these. So why not just give us a brief description of kind of what the form factor of that is?
Yeah, maybe can show the device here. So it's a slightly, well, it's about the size of a smartphone. It's just a little thicker because, of course, we add the extended battery and multiple cameras and the tactile buttons there that are on the surface, such that they are easy to recognize by touch. But it's a device, like if you see the size of my hand, it's about the size of a smartphone there.
But you have a pager. Remember the old pagers we used to wear on our belt?
Yep. Yeah, you're right.
It's like a Nokia sort of pre-smartphone sort of size. And as LP mentioned, the device does have a tactile 5-way selector switch with arrows, as well as 4 additional buttons on the top face. Those are used to gather that information and kind of go into the various modes, as well as a single button for the where am I or direction of travel, a single button to dictate or speak into the device, and then a single button for going to landmarks or addresses and things. So there are a number of buttons, but it is not cluttered. We always build devices that we know that buttons are very important. It's what will set this device apart from other things out there today, but we don't want it to be overwhelming. Same way on the faces. Your left face, your left edge of the device simply has volume buttons. Your right edge of the device has a single power button as well as a record button for your landmarks. And then additionally, there is one other, on the top face, the face furthest away from you, there is nothing on the device. It's very clean. Toward yourself, if it's laying on a table, you have a USB-C port for charging, and then an 1/8 inch or 3.5 millimeter audio jack for plugging in headphones. And then on the back, you have 2 cameras, both a wide angle and kind of narrow camera used for that address detection, as well as used for optical character recognition. So it's very slick and clean. It's not cluttered with buttons and all sorts of different things, but it is certainly something that will allow you to have full push button control. There's no touch screen on the device.
So now that we're all on the same page, and all the listeners sort of who may be not familiar with this device and with Humanware know what we're talking about. As we described the device, we compared it to a smartphone a bunch of times, which is super interesting because that immediately brings up what I think is going to be the first question in many people's minds when we talk about these features and when we talk about what it does, and even when we describe the device, which is, why not just use a smartphone? And what are the advantages of having another separate device to carry around and to charge and to look after and to take care of and to buy and all of this stuff? So Peter, why don't I throw that at you? Why this? Why not a smartphone?
It's a great question, and I think it comes up often when we are in this space, and not just the navigation space, but we get a very similar question with our audiobook consumption products. We get the similar question with our Braille note-taking products. Why not use a mainstream device? And specifically to this product, so specifically to navigation, there are some pieces that do set the product apart. And I'm an iPhone user. I use navigation apps frequently. There are several out there, things like Good Maps, for instance, Good Maps Explorer or others. They're very useful. We use them a lot. However, there are a couple of pieces. Number one, you have when you're using a device like this, you are not using data. The maps, everything is stored offline. So you are not needing to draw down your battery on your smartphone, firstly, as we know apps, especially navigation apps and OCR apps. So we all open many of those apps, ranging from Seeing AI to apps such as Waze, if you're just driving in your car. Those will draw down your battery very quickly. As blind people, we don't travel oftentimes we're not driving in a car, right? Maybe we're on a bus or we're somewhere. We can't just plug it in to a USB port conveniently sitting in our cup holder center console. So battery life is very important. This does allow you it's about 20 hours of battery life. So number one is your battery life, your data consumption. More importantly, though, are those differentiating features. Yes, we can certainly use apps on our phone to get from point A to point B. But what those apps don't always give us are the direction, the exact address range, the direction of travel, meaning what intersection is coming and what type of intersection. The ability to record routes and walk them again later is something that's very unique to a device like this. And I'm not saying to get walking directions, but more so to remember the streets you're walking on. Something that is very useful, especially if you have someone who is newer to vision loss or is not a very confident traveler. It can be really nice to know that the route you're walking is going to be consistent and you can backtrack and return along that exact same route to your starting point. To go a step further, the push button side. I live in the middle of a major city. I live in the middle of Chicago. I am not very comfortable walking around with my iPhone out held up near my ear or kind of using that in one-handed operation, right? Using the touchscreen and kind of getting feedback with one hand. Certainly with a device like this that you can put there is a lanyard as well as a belt clip and holster. You are able to secure the device to yourself. It's not going to be something that most people will recognize, right? And again, you're not just holding your phone up. So there are some advantages there. I think the other piece is when we build a device, we build that product for 100% of our users being visually impaired or blind. When we think about the UX and the UI, we think about user design. We think about everything that goes into it is built for that user. When we use a smartphone, and I use these apps all the time, they're wonderful, but things change very quickly. Primarily speaking, the apps that you're using are designed for general use and maybe accessibility is bolted on or added to an application later. When we build something, we know that our users, our beta testers, everyone who is using this is giving us feedback that we're able to incorporate not just into the feature set, but also into the hardware, the placement of cameras, the type of textures we use, the buttons, all of that stuff comes into play. So it is, even though they're very comparable, and certainly somebody will say, I use my iPhone, and I say, that's great. Or, I use my Android apps and I use my smartphone. That's wonderful. We're not saying, that somebody shouldn't, but there are lots of advantages to having a single standalone device like this.
Yeah, absolutely. I mean, I've been using one for the last little while, and as someone who's maybe a little bit skeptical, and it is very restful to travel without bone conduction headphones or without the AirPods with transparency and sort of something yapping at you all the time, because obviously not getting your Facebook notifications, the Stellar Trek is going to talk a little bit less.
Distraction factors also comes into play for sure, right? I mean, and this is going to give you only that information that's pertinent to you, and you can adjust that verbosity as well. But certainly that is an entirely other side, is you don't have that distraction. You know that this device is primarily focused on that navigation sector.
So, I mean, one of the things that this brings to my mind that we sort of a kind of narrative that I think sometimes can exist in our community is this idea that, like, oh well, we had note takers and we had readers and we had GPS devices until the phone got good enough and it could eat all of those devices and be your one thing, and sort of this story of like, oh well, blindness devices are temporary until the mainstream technology gets around limitation X, Y, or Z. Do you, at Humanware, it sounds like you don't believe that to be the case, and you feel like there will always be a place for this kind of blindness-specific innovation that, for various reasons, maybe can't be replicated in a quote-unquote mainstream device.
I think LP, I mean, you're in a unique position to kind of see the exploratory side of this. I mean, and of course I'm going to piggyback on where you go, but it really, there is a need for these specific companies and really to look at and be tied directly into the user base. Can you talk a little bit about that innovation side, LP?
Sure, yeah. And it's interesting because there's an evolution as well in the assistive technology domain. That before, everybody was making these kind of unique closed environment devices that were standalone. and the Stellar Trek is one of them, and it's designed like this on purpose. But we also have more and more of these products where, for example, our Connect 12, which is a tablet, an Android-based tablet that is running our own software, but it also gives you the ability to open any applications you want. So we're not actually, we don't see it as the mainstream versus us. It's more, there's synergies, I think, between the mainstream and the assistive technology there. But still, we think there will always be a need for dedicated devices that are really purpose designed and built for the community we serve. And of course, the Stellar Trek is really the perfect example of that.
And I think the other pieces and what we strive to do is, you know, when we use a third-party application on a mainstream device or a Windows program or anything with a screen reader, somebody has taken that product and has made or you know has done some work to make that accessible to us. And accessibility is somewhat of a buzzword. We have a lot of friends now in this industry who will hark on this, and you'll hear this message more than just from myself and Humanware. But there is a big difference between accessibility and usability. You know, when we use an app like, oh, let's just say something like Gmail, for instance, it is accessible on a smartphone. What Humanware tries to do, and when we build our own mail client, for instance, on a Braille product, or in this case on the Stellar Trek side, we're taking what is already accessible and we're making it more usable. How do we improve the user interface to be more conducive to somebody who is blind, who takes in the world linearly? We don't look at a screen and soak up all that information. We move through very linear menus. We work through structures that are not, you know, we take in one line at a time or hear one audio phrase at a time. We can't just glance at a screen and have our eyes drawn to a certain point on that screen. So when we build products, and that is why the companies like Humanware, there still is a need for this type of sort of manufacturer. You know, we're looking at improving things and not just looking at, oh, we made this accessible, it's great, now go use it. It's just as much about usability.
It's a very good point, Peter. And just to add to what you say, you know, and again, this is nothing against the mainstream companies. They make, of course, great products that are used by everybody. But, you know, often, sadly, sometimes the accessibility is kind of an afterthought. It's they make a device first for the mainstream user, and then now let's make sure it is accessible. And of course, not only Humanware, but every companies in our field, and that's what they do. They do completely differently. They say, well, what's the solution we need to find for this specific problem or this specific need? And we make the solution, we design the solution from ground up, thinking about accessibility, thinking about usability, and how to make it useful, and not just an afterthought to make sure that it is accessible. So
and that's where, oh, sorry, one quick thing they're saying, you know, for anyone out there who is looking at getting started in this space or wants to learn more, you know, the making something accessible is the beginning of the journey. To really complete that journey, it really does require a lot of insight from the community at large, be it whether that's, you know, you're making a product for somebody, you know, whether it's augmentative communication, in this case, vision loss. You know, it's one thing to just say, well, I want to solve a problem, I'm going to make this accessible. It's a whole nother story to kind of dive in. You really want to do the due diligence and actually seeking input from the community at large, and then understanding how that can change the way you're thinking about designing the product. So it is, what LP is saying is absolutely spot on as well. And I think oftentimes we get caught up just in, well, it's accessible. And the other side is on the smartphone and on some of these pieces that are very fluid, they're very dynamic. We wake up and tomorrow the app I've used so successfully for the last 8 months or 2 years is completely inaccessible, or the usability has changed so much that it's going to take me quite a bit of time to relearn how to use it. And sometimes that isn't even a possibility. So we do have to contend with these updates on the mainstream side that at times can very much impact the way we're using these types of applications.
So, I mean, as we think about the future, and as we think about where all this is going, that kind of brings up so many interesting thoughts and questions for me that I would love to get your input on. I mean, first of all, I couldn't agree more with the need for community feedback. I think over on the blindness community over on Reddit, we get a new post every week with somebody who has a great new idea for a smart cane, sort of this is their first time ever interacting with someone who's blind. But at the same time, it feels like it's a little bit incumbent on us to encourage these mainstream companies to think usability first rather than accessibility first, and that really makes me wonder, because we've talked a little bit about Humanware is building some of their devices on top of the Android platform, and we're taking these sort of so-called mainstream devices and getting accessibility features and making them accessible. Have there been wins, and have there been thoughts and learnings that have come from kind of an accessibility focused device and that have filtered their way back into the mainstream? I'm curious if in kind of the 35 years of Humanware you've seen examples of that happening.
Well, I think you can point LP to something pretty quickly. I mean, if you think about the kind of the what we've worked on with the door detection side is available on iPhone, correct? I mean,
right. Yeah, true. Because on the Stellar Trek, there is the two cameras. They are used to detect doors. So when you're going from point A to point B, when you arrive at that point B, usually it's not on the sidewalk, right? You want to go to some friend's place. So of course we have the possibility with the built-in AI to localize doors and guide the user to that door, which is a cool feature. And we've been happily surprised to see that it's been, I think, not sure if it's an official feature or some kind of a beta feature on the iPhone. I think it's on the latest iOS version. So it's good, actually. We see this as all positive, and also during the course of the lifetime of Humanware, we hope that we have influenced positively other industries, including the mainstream industry, to have more accessible and more usable ways of using their products. So yeah, well, that's our mission.
Yeah, and I do
to serve people.
I think we are seeing it. I think another place we've seen it for sure in this AT field is with, think of barcode recognition or OCR. OCR was something that was very much used just for the blind at its inception. I mean, it was when Ray Kurzweil did all the things he did, and when they built that ecosystem. And now think of all the apps in our lives that use OCR in some form. I think that'd be your first example you can point to, but there are lots of others. Think of barcode reading. Think of lots of pieces that did start as solutions for our community or any sort of disabled community, and now are just part of inclusive design. I would even go as far as to say, think of something like a sliding door, an automatic door at a grocery store. Certainly it helps somebody in a wheelchair, but ultimately it helps every single person who has a kiddo in one hand and is pushing a cart and needs to get in and out of that store quickly. That type of inclusive design maybe starts here, but we are seeing it splash back or filter back into just the general sort of flow of product design. And that's a great thing.
Yeah, I mean, I think that's the important. Oh, go.
Sorry, Samuel. I was just saying that actually the first talking GPS was in 2003, when Humanware had this first version of the what, I don't really even remember the name, but I think it was a Trekker
before the Maestro. There was
yeah, but it was a big device using a some kind of a Palm Pilot at that time, and it evolved so much. But now, even Google with Google Maps, they have like audio feedback and cues when you're walking around with their application, which is great.
But of course, I mean, that's what I wanted to sort of highlight is that, like, Humanware and accessibility devices and specialty devices are part of this ongoing conversation. and the ongoing innovation that happens across the accessibility field, as opposed to just sort of being their own thing, I think, as we can sometimes fall into thinking about them. And so that said, when we are developing a device like, or when you're developing a device like the Stellar Trek, there are unique needs because it is an offline device. It is a device that doesn't necessarily have access to data, and yet you are bringing AI, whether it's door detection or whether it's OCR, onto this device. And so I think when people think about AI right now, they think about like big data, they think about the cloud, they think about all of this stuff. And so what are the considerations as we think about bringing that into the offline device? And where do we think that offline kind of private personal AI is going as we look forward in the next couple of years?
Yeah, well, that's a very great question, because we did put years of research actually in making embedded standalone AI that is not connected to the cloud. Of course, cloud computing has so much power and possibilities, and this is great, of course. But again, for the reasons that Peter mentioned at the beginning, we want to make sure that the person, even if a person is off the grid, is able to get his or her direction to safety, to back to their home or the bus station, and so on. And so that's why we did spend so much time developing this embedded AI engine that is in that device. And the cool thing about it is that it's very the way we designed it. It's really future-proof for other features we will add later on. I think last year when we gave a glimpse of that product, we already started to sneak peek some of the features that we would eventually have available for the Stellar Trek. And there's a lot of them that are being developed at this moment. So, and all of them will be standalone, without cloud computing, without connections. So that's what we think will bring so much value to this device.
And I think if you want to point at specifics, you can really look at some of what is already currently available, both in beta as well as in the mainstream on smartphones. So we do have apps that can try to identify traffic lights. We do have apps that can look at obstacle or sort of detecting various crosswalks, other things. We do have apps that can do barcodes, or, we need to be looking at this sort of piece and adapting that and making it certainly usable at an offline sort of side of things, and then B, looking at how to manage that usability of those sorts of apps, because it is very difficult with any of this AI. It's very difficult for a blind user to function when you're supposed to point your camera at something and get a result. That's not something that is easy, right? We need guidance. That needs to be a part of the AI we build as well. It's not just point and shoot, it's where do I point to then shoot and get my picture. So that can be a major challenge.
And something that we haven't mentioned yet is also the robustness of the solution, because if you want people to rely on the device, you cannot have like too many second guess, right? So is this a sidewalk, or is it the middle of the street? It makes a difference, of course.
Yeah, absolutely. It's a safety thing. We've only got a minute left. This has been a great, incredible panel, and I wish we'd go on for another 30 minutes. But to close us off, what are you most excited about for this time next year? What's the big improvement that you're thinking you're going to see and that you're most excited about in like 30 seconds?
Well, we want to see, of course, more features, object detection, object localizations as well. For example, where are your keys on your table and things like that. So these are things that are in the roadmap that we'll hopefully have ready for next year.
Yeah, and I think to second that from an outdoors perspective, certainly the variables, the environmental variables. I think about the pedestrian traffic signals and other things that are very pertinent and something we need to be looking at and assessing, because there are so many variables in our environment when we travel, and also variables that the camera needs to account for, because you need to think of when it's raining or snowing or lights reflecting, or it's dark or it's dusk or it's dawn or it's midday or it's beautiful. right? That's just the tip of the iceberg. So
in a really fascinating way, we deal with the same problems that self-driving cars deal with, don't we?
Right.
But that said, I think that brings us to a close on our time here today. Great conversation. Thanks so much to the both of you for being here and for really having that open talk about where specialty devices are now and where they're headed and the part that they play in the ongoing conversation about the future of accessibility.
Thanks tremendously, Sam. We appreciate it. Thank you to SciTech Global. And we definitely look forward to seeing everyone in person as soon as we can, and certainly being back in a virtual space sooner than later as well. So thank you.
I'm adding my words to Peter. Yeah, thanks everybody for the organization of this. Thank you, Sam, and thank you, SciTech Global.
That concludes our section on hardware. Now we're going to move over to the AI aisle, where we're going to find out if AI will be our salvation or our doom. I hope I sounded like Dr. Evil there. So when people hear AI, they don't always realize that asking Google Maps for a set of directions, that's AI. Asking Alexa for a sports score, that's AI. Seeing AI, giving you results, that's AI. Next, we're going to hear from two world-renowned technologists who build this stuff. Our first AI session is with two famous AI technologists who are going to discuss why people have an overblown opinion of the current state of AI. The session will be moderated by Ned Desmond, the founder and executive producer of SciTech Global. The session is called The Problem with AI.
The Problem with AI. Moderator Ned Desmond, speakers Dave Ferrucci and Gary Marcus.
Thank you for that introduction, Brian. Let me warn everyone at the outset that this is the one session at SciTech Global in which we are not talking about accessibility, at least not directly. Instead, our topic is the debate within artificial intelligence circles about deep learning, the overwhelmingly dominant model for AI today. In the view of many AI experts, this deep learning approach, with its reliance on massive amounts of data and immense computing power, is the unquestioned future of AI. Our guests don't agree. They have serious doubts about deep learning's potential to really advance AI, or even overcome its own well-known limitations. You might say our guests are dissidents in a world dominated by deep learning AI. And they are dangerously well-credentialed dissidents. So let me introduce them. Gary Marcus is a leading voice in artificial intelligence. He's a scientist, best-selling author, and serial entrepreneur, founder of Robust AI and Geometric AI. He is well known for his challenges to contemporary AI, anticipating many of the current limitations decades in advance, and for his research in human language development and cognitive neuroscience. Gary is Emeritus Professor of Psychology and Neuroscience at NYU and author of 5 books, including his most recent, Rebooting AI, one of Forbes' 7 must-read books in AI. Dave Ferrucci is an award-winning artificial intelligence researcher who started and led the IBM Watson team from its inception through its landmark Jeopardy success in 2011. Dave has worked for more than 25 years in AI, and his passion is to design computers that fluently think, learn, and communicate. That inspired him to found Elemental Cognition in 2015. Elemental Cognition's mission is to accelerate and improve the quality and explicability of AI decision-making in the face of growing complexity, shortages of accessible expertise, and overwhelming data. Dave graduated from Rensselaer Polytechnic Institute with a PhD in computer science and has over 100 patents and publications. Dave and Gary know each other well, and they'll drive this conversation for the most part. But let me get them started with a question that goes to the heart of this AI debate. Dave and Gary, what is deep learning AI good for, and what are its limitations?
I think you wanted Dave to go first since you said it in that order.
I'm happy to do that. Deep learning is from my perspective, I mean, it's an incredible invention, really, and it's fabulous at detecting patterns in large quantities of data. It's fabulous at doing pattern recognition based on how the data occur. It's changing the face of AI. It has changed the face of AI because we can use it to make predictions, to extrapolate from data in a way to learn the patterns without a lot of human programming. And in the past, this was extremely difficult to do. So it's remarkable in that regard. What it's lacking is the ability to understand the reasons why that data occurs the way it does. It doesn't build an understanding or the causal models that we need to make more thoughtful, rational decisions. Some complain about the biases, but deep learning is designed exactly to find the biases in the data and to mimic them. That's what it's designed to do. And by design, it's very good at that. And where that allows us to make predictions we couldn't otherwise make, or to extrapolate the data, or to find functions in the data that we otherwise would be impossible or take forever to find, is phenomenal. Where we want partners to help us make rational, thoughtful decisions that we can explain, it doesn't do that. It's not even designed to do that, really.
I completely agree with Dave. This is not going to be a debate where we go back and forth and disagree about a lot, although we may find some things to disagree about. The way I would put it is that these systems are skilled mimics. They're, for example, really good at making fluent language, but they're not in touch with reality and they can't reason about reality. And that ties to this notion of sort of causation versus correlation that Dave was hinting at. So we get problems like when they generate fluent text, there's also often misinformation there. So one example that I recall from the sequel to GPT-3 called Instruct GPT is somebody asked it about eating socks after meditating. And the system fluently said, some experts believe that it's good to eat socks after meditating because it brings you out of the meditative trance or something like that. Well, it sounds fluent. It sounds like something a human would say, but it's not something that it found in an actual source. It's all unsourced. It's just putting together words and sequences like auto-predict might do when you're in your text completion, predictive text.
Sorry, go ahead, Gary.
So as Dave is saying, it doesn't really understand what's going on. Here's an easy thing to remember. The phrase deep learning invokes a notion of theoretical depth, of conceptual depth, but it really just means how many layers you have in a neural network. And the level of comprehension that we want, such that a system that is talking about socks and meditation actually understands the potential relation or non-relation between those, is far outside the bounds of the deep learning systems by themselves. I don't think either Dave or I want to get rid of deep learning, but I think we both think there are serious holes in what it can do. And I think we both think that a lot of people out there see it as a kind of universal solvent, that it's not. It's a component in a larger system that I think is fine, but the larger system needs to be able to reason, to have common sense, kinds of things that I'm thinking about, that Dave is thinking about at his company.
Yeah, I think if a couple of good points you made, Gary. So first of all, I like that point about deep learning. I think the notion of deep, when we hear that, it evokes deep understanding. But in fact, as you said, it comes from how many layers in the neural network and the power of that neural network to find functions in the data, basically relationships in the data. And so I think that that's definitely could contribute to the expectations around it, that it's deeply comprehending, which is a very different thing than finding those statistical patterns. I like the other point too, is like, one of the metaphors I use, this notion of a super parrot. We think about parrots and how they can listen to us and they can start guessing or actually saying the next thing that we might say. But do we imagine they really understand the depth of the mental models that we have, the meaning we associate with those words and those experiences, just because they can make that prediction? And the other thing is what I find really useful when I think about AI. I like to think about human cognition and how humans think, because I think humans think in different ways. And the way we think sort of creates this model for us to think about how AI works. So one thing we do is we make statistical predictions. We just extrapolate from the data. In fact, even in language generation, I'm sure we've all experienced this moment, even in ourselves or in others, where we're listening to a conversation or engaged in a debate of sorts, and we formulate a sentence. And then someone challenges us on, wait a second, that doesn't make any sense. And we say, oh, you know what? You're right. I didn't really think about it, right? But my brain was able to kind of formulate the words, make a grammatically correct structure that sounded good. But when I really think about it, I wasn't making the connections. It really didn't reflect an understanding. Our brains work both ways. Our brains work as sort of statistical language models, but they also work as rational thought, machines that can think about the meaning and the logical implications, the mental models.
You can think about Danny Kahneman's famous distinction between system 1 and system 2, which I like to call the reflexive system. It's kind of automatic, it's fast. It's probably too crude a distinction, but we start with that. So you have this reflexive system, and then you have the deliberative system, which is what Dave is saying, that makes rational decisions. I don't like to call it the rational system because it's not always right, but it's at least trying. It's like the Supreme Court. It's deliberating. Maybe it doesn't come to the right conclusion, but it is trying to make those logical connections between.
Well, it's transparent. It can be, it should be transparent in how it's making the judgments it's making. It can explain them in some sort of rational deductive process.
So take my socks and meditation example, right? The system can't actually tell you why it has said some experts believe that it's okay to eat socks after meditation because blah, blah, blah. It can spit out a string of words, but you couldn't pursue it. There's no internal thing in the system that you could inspect the way with a classical AI system or just a classical computer programming system. You could say, well, the reason it's made this mistake is because, this value in this database is set to the wrong thing. It's this big abstract collection of predicting numbers about sequences in text. It's not interpretable. It's not that there's something in there that represents a database of like, this expert believes this and this expert believes that. It can't say, well, I found this on some web page because it didn't find it on a web page. It just made it up, and it's not grounded in reality. The deliberative system is at least grounded in our model of reality. I was thinking about the parrots a second ago and thinking, is that fair to the parrots? Because in a certain way, they are like parrots, because parrots, when they use language, don't really much understand the language, although there's some interesting work on that. But when the parrot thinks about the world and like flies through a room, it has a representation of the entities in the world that it's interacting with. So it is grounded. You could fool the parrot. You could put it in a VR system. But the parrot has some representation of reality that it's working over, that it's analyzing. And system 2 reasoning should be about that. But deep learning alone doesn't really do that.
I think one of the things you bring up, though, particularly with the parrot example, is, when we think about how we assign meaning, and what that evokes ultimately is relativistic, meaning that you and I have to assign similar meanings. We have to have a shared understanding in order to communicate. In order for me to produce an argument that you can agree with or that you can evaluate or probe, we have to have a shared understanding around the meaning of the words and the phrases and so forth. And, when we think about AI, we have to think about, what do we expect from the machine? Do we expect the machine to project a shared?
Nope, we may have lost Dave for a second.
It's not anything like the understanding that we're producing right now. In fact, quite deliberately, it's designed to look at the artifact much more as a pattern of numbers or words, and to extrapolate from that pattern to say, here's what this pattern alone would suggest, as opposed to build that shared understanding.
I actually think that deep learning is dangerous in a certain sense. And the reason I think it's dangerous hinges on the kinds of things Dave was just talking about. So we tend to attribute a shared understanding to these systems that don't actually have it. So when it talks about the socks and meditation and stuff, you assume that any system, any person that talks about socks and meditating knows what it's talking about, but it doesn't. It's actually just saying the statistics of, this word following this word is this other thing. It's very difficult for us as human beings to recognize how superficial the understanding of those systems are.
This is a human cognition challenge, right?
It is. We
fool each other that way as well.
That's right. I mean, it goes back to Eliza in 1965. You had a psychiatrist. All it was doing was keyword matching, but some people kind of fell for it. So we're not built to discriminate these things. If we're going to make AI available that has conversations with people and that has control over, I don't know, air traffic grids or home robots or whatever, it's really important that those systems understand the world as we do. So like, you don't want your home robot to sometimes mistake what you say is metaphorical as being literal, for example, because you want that system to have an understanding of the world. Okay?
I think we have to be careful to trash deep learning. I mean, it can be used in dangerous ways, I agree. But when we think holistically about intelligence, it plays a very, very significant role. And, it's like you don't want to throw the baby out with the bathwater, right? It plays a very, very significant role, which is to look at the data and to generate hypotheses that are consistent with how the data occurs. Because those hypotheses now can feed systems that can model and reason in ways that do build and advance a shared understanding. So this goes back to your point about Daniel Kahneman and the system 1 and system 2. When you put these things together, you have more of the holistic view of AI, in my opinion.
Yeah, I mean, I don't think we should throw the baby out with the bathwater either. I'll clarify that I think the real problem is expecting too much from the stuff that's more like system 1 and expecting it to do the system 2. So I think we agree that you want to use this stuff. They're great techniques for doing certain kinds of pattern recognition. You shouldn't throw them away, but you also have to be realistic about what they can do and what they can't do. And that requires training and understanding some of the psychological phenomena that you're really trying to capture with your machines. And so, no, we shouldn't be throwing away deep learning, but we have to recognize we need more. And part of what Dave is doing in his company is to try to look at the other side of that divide, try to say, well, how do we represent in a machine common sense knowledge? How do we get a machine to do argumentation? So, for example, lots of things in the world, they might be true, they might be false. We often don't know. We want to be able to evaluate different arguments. I think part of what Dave is working on is how do you get machines to do that?
Yeah, at Elemental Cognition, the view is we want machines to always be able to explain why, to help us solve problems, but not to make black box predictions. It's okay to say, I'm thinking this because here's my understanding of the world. And by the way, part of that understanding includes a statistical prediction from the data. But as long as we can model that holistic argument, we equip humans with the ability to say, here's my understanding. Here's why I'm making this decision versus that decision, as opposed to extrapolate and say, this is just a correlation. I don't really know what's going on. I mean, that's again, encompassed in a more holistic intelligence. So my big thing is like deep learning, big, important part of the answer, amazing advance, critical advance. How do we include it in a holistic architecture that really addresses the partner intelligence we want when we think about AI?
I'm going to give you a little insight into Dave, because I've been talking to him a bunch lately and thinking about some of his earlier work too, on Jeopardy, and something just sort of clicked, understanding Dave. So Dave right now is telling you about the question of why. He's saying a good system needs to be able to answer why. And one of the innovations around Jeopardy was basically giving an answer to how sure are you? So you had a panel you could see, and he can tell you more, obviously, but in Jeopardy with Watson, it would say how sure it was of its answers. And so that's another piece of like metacognition that's really important in doing good cognition. You want to know how sure you are of yourself. You want to know why you got that answer. You don't want to just spit out an answer and maybe it's right, maybe it's wrong. You want to be able to do something.
Well, interesting, even the Watson system would be able to, while it couldn't give you a causal model where it described the places and the events and how they're related and why something happened or something else happened, it did allow you to interrogate why it preferred one answer over the other in terms of concepts that humans could relate to. So it can say things like, I've analyzed this passage from a temporal perspective. It was aligned with, this answer was better than that answer because it was more aligned with the question. From a geospatial perspective, from a classification perspective. So it wasn't a completely opaque model. It actually broke the problem down into independent features. Each of those features were trained with machine learning, but it classified them in ways that at least you can get what we called an evidence profile of why it thought this answer was better than that answer.
And so the ultimate thing that Dave and I would both like to see is what he just described as causal models. So like, let's say I'm a domestic robot in your house, like Elon Musk's Optimus is supposed to be, looks like C-3PO or whatever. And now you say something like, can you clean up the living room? And now it has to infer from some unstated things what exactly you mean by that. What do you mean by clean up the living room? So for example, do you want literally everything out of the living room? Do you want to cut up the couch and put it in the closet? Probably not, because the couch is of value to you. And so the machine has to understand what you're thinking is important, what's in there physically. It's not enough to just have like some statistical.
Well, I'm gonna put my deep learning hat on, and I'm gonna argue and say, with enough data, it can associate cleaning the room with an expected result.
Well, I mean, that's the interesting question about outliers, right? I mean, this is sort of what's going on with driving. Is the thesis was with enough data, we'll be able to make all our unprotected left turns and so forth. And Cade Metz wrote in the Times just today about a ride in a Tesla, and there's clearly still outlier problems where even with all the data that Tesla has collected, the machine is still stymied when things are a little bit different than before.
And I think you have to look at each application because there's going to be these asymmetrical risks with regard to outliers, right? And within some cone of expectations, but there's always this answer, however unsatisfying it might be. The last 300 million times I cleaned the room, you were happy with this result. Right. I mean, it's really based on, again, extrapolating from the data. And then, of course, as I said, there's these outliers, and then how risky are those outliers? I mean, if it's a life and death situation, those outliers matter more than
That's right. This is why the biggest financial successes of AI have all been around advertising, because if you pick the wrong advertisement, there's essentially no cost to it. Nobody ever dies because you showed the wrong commercial. Whereas in driverless cars, it's still all kind of in beta after 25 years because the cost of error is much higher. And so Dave's absolutely right. These are empirical questions. In speech recognition, we're pretty satisfied with 99% correct. It's not 100% correct. Sometimes it's annoying when you dictate something in your car and it's noisy, but most of the time it helps you. The cost of error isn't too high, and mostly you don't have to deal so much with the outlier condition. So every domain, like when you're thinking about this commercially, you have to ask, what's the cost of error? How variable are the data going to be today and the next? My own feeling is that domestic robots are a serious problem because people have very different houses from one another. You have very different things about what is important to them and so forth. And my guess is you are going to have those outlier cases in spades. It turns out that driverless cars has hinged more on outliers than I think people expected. They thought, well, the roads are all basically the same. It's going to be fine. And it wasn't. So some domains are going to be okay and some aren't. And sometimes you're going to be able to take a domain and bend it to your will. Like you could build a new city from scratch around driverless cars, changing how the pedestrians interacted with the cars and probably make them work. If you want to make it work in Bombay, it's hard.
Here's a funny reality with regard to deep learning is that I've actually experienced people complaining about deep learning systems, giving them the wrong answers. And then the data scientist says, well, but this is what the data reflects. And the answer is, well, I don't really think those answers are right. They're not upholding how we view the problem, how we reason about it, what we think the right judgments and values are. So go and change the data so that the machine learning does the right thing.
Well, here's a problem related to that that's really hard to solve, has not yet been solved. We now have these generative models like DALL-E that you mentioned and Stable Diffusion, which are fabulous. They're also incredibly biased. So if you type in CEO, you're guaranteed to get a white male, for example. And there's a brand new paper that I just tweeted about. I'm trying to think who the authors are. It goes in this in excruciating detail, showing that for many, many examples you wouldn't even immediately think about, you get all of this kind of stereotyping. And there, the system is a direct reflection of the data that are out there,
right. And
not a reflection of what we want the world to be like.
Exactly.
And not actually even a reflection, here's the interesting part, of the actual world, but of the data that are in the world. So take CEOs as being white males. That's partly because CEOs are overrepresented in movies that are then in the database. So if you actually took representation, you would see, like, I think her name's Safra Katz of Oracle should be in your top 50 pictures of CEO, but she won't show up there because she's not in the news as much as Elon Musk. And so you get more representation of Elon Musk because people talk about him. But sometimes the systems don't even
So there's the reality, then there's the data, then there's the reality that the data might be biased and not reflect what you want the system to actually do. And it's sort of interesting when you look at applications of AI or of deep learning to sit back and say, what do I really expect the system to do? Is the data that I'm training the system with representative of the phenomenon, the behavior that I desire? And of course, it's kind of silly when I could write down the behavior I desire. Why would I go muck with the data if I could just write it down and program it?
Well, and that's the real problem, is we don't yet have, well, this is the kind of thing I think Dave is trying to work on, systems where we can fluidly even represent what our desires are and mix that with the data. So you really want an answer to this, a mix of data and, let's say, human values. So human values would be like,
human values, human judgment, decision processes. I should make it very easy to capture those, to evolve those, but then to inform them with what's actually going on, the patterns that are in the actual data and the empirical data. And those are the two sides of intelligence.
That is the holy grail going forward, is to be able to connect the human values that you might express explicitly. They can also be laws, like just the driver's handbook for California. Things that are represented in language, and then relate that to the data. Right now, we're really good at the data, and we're pretty good at doing symbolic reasoning on stuff that's kind of innately specified in some particular architecture, and not really good at bringing those together, except in our domain.
Exactly. Right. That's the vision. Right.
And how do we make it better?
Did we answer the first question now?
I was going to ask an excellent job on the first question. So can deep learning become better, or is it going to take fundamentally new AI architectures?
Yeah, that's the $1 million question. I mean, that's the interesting philosophical question, I should say. I don't know if it's the $1 million question. It's definitely.
I think it's $1 trillion question. We found something to disagree about.
It's a $1 trillion question, maybe. The reason why I say it's such an interesting philosophical question is because, and I'm quite frankly agnostic to that right now, but like I believe that that when you think about the behavior that you want, and I'm a big proponent about stepping back and saying, forget about how we do it. What behavior do you really want out of these systems? And I think when you look at that, I don't know the answer to whether or not deep learning, when you look at that holistic behavior, like the thing we've been describing, something that can analyze data, generate hypotheses, understand the possibilities, being able to meta reason about the data, to what extent does it cover the phenomenon, to then fit that to a model, a shared understanding, conceptual model that can now reason over, so it can give answers, it can explain those answers, or give predictions, or it can make arguments, it can evidence those arguments, it can understand whether or not some of the assumptions it makes are based on statistical patterns or whether it's based on deductive arguments, right? This is the rational, intelligence, I think, that we can we can describe, and I don't think it's that hard to describe. It's all over science fiction, right? I mean, we've imagined this for decades and decades. It's above and beyond in many ways. It corrects for problems with human cognition and some of our cognitive biases. Like, that's this vision. So now when we say, can deep learning get there? Maybe. I think, I don't know, right? I don't think anybody knows yet. I mean, I'd love to hear arguments about it. My sense is, I don't know. I'm sort of agnostic. I'm like, maybe. But there's one thing that's probably true if deep learning can get there on its own. And that is, you have to give it the data to train on. There are a couple of problems. One is that we don't articulate the data in vast quantities to train a machine about how to really do all of that. How to reason, how to think, how to do this meta reasoning and this, deductive, system, deductive reasoning. Where's the data that trains machines on how to do that? Do we articulate that? Is that in the form we can train machines on? So that's kind of question number one. It's really not. There's some work on that, but that's like a big nut. And then the other nut is, when we think and build shared understanding, we react to features that are generated by our wetware, that are generated by our brain being human. That's not in the mix right now. And there's a lot there. So those are two problems. So on one hand, I'm like, maybe, but those are two problems I see with machine learning, deep learning alone getting there.
So first of all, technically, I'm agnostic too. I'm agnostic about almost everything, in the sense that I'm a scientist. I look at the data. I try to update based on the data. My view is it's unlikely.
So you're Bayesian.
So I'm a Bayesian, exactly. And, I don't see a lot of, I've been looking at these particular issues for about 30 years, writing about how it is that deep learning systems don't do these kinds of reasoning things and extrapolation beyond the data. We call it nowadays distribution shift. I was one of the first people to write about that in 1998. I don't see a lot of movement on those problems. All the movement I see is what we call within distribution generalization rather than outside distribution generalization. And I don't see how you can do the reasoning without it. This doesn't mean that I think it's literally impossible to fathom, but it's like, I keep seeing these kinds of approaches and they don't look to me like they're really working, and they keep breaking down in the places where I would anticipate them. And I start to have some confidence in my own predictions over time.
Well, what do you say, Gary, about the view that the human brain is essentially an inductive machine and we figured out how to do system one and system two?
I think it's innate that we have system one and system two. I don't think that we have induced the variability to do logical reasoning. I have data from when I used to be an experimental developmental psychologist showing that babies could learn abstract rules at 7 months old. And then what happens in developmental psychology is you do an experiment and someone else says, I can get even younger kids to do it. So somebody replicated my work, but did it in newborns. So they showed newborns could represent abstract rules. Another friend of mine, Luca Benatti, actually a couple of different friends of mine, have done work showing some basic reasoning, like disjunctive syllogisms. If I know it's A, or if I know it's either A or B, and I know it's not A, then I can.
Yeah, but when you say innate, you're basically hardwired into the brain, and then you have to kind of go to, well, how did that occur? And that occurred through an evolutionary process. Is the evolution?
That's right. And
the evolutionary process probably also is sort of, if you were to give it a shape, it would probably still be inductive.
Well, I mean, I guess there's a couple of things. So I wrote a whole book about this called The Birth of the Mind in 2004, which was about, if things are innate, what are the processes of developmental biology by which they might be there? There is some abstract level at which you can call evolution learning, but the causal mechanisms are quite different from the other things that we associate with learning. So there's kind of parameter setting in both cases, but in one case it's building a genotype that creates a phenotype that does something in advance of experience, and the other, it's what do you do with the experience?
That succeeds, right?
And so my view is that the minimum that you need to have in an adequate cognitive system like ours or in an AI is you have to have, let's say, pre-wired, I don't like the word hardwired, but pre-wired capacities for things like representing time and space and object and other agents. And if you have those basic things in place, and this is a view also associated with the philosopher Immanuel Kant and with the developmental psychologist Liz Spelke, if you have those basic things in place, also with Noam Chomsky, then you can go learn some other stuff. So I take a pretty strong position that you need some innate nucleus that you then sort things around. And I think pure deep learning doesn't have that, though there's a conversation about what deep learning even means and how the term changes over time that we could have. But so that was part one. Part two is in terms of the data, I think there's some data we're unlikely to get. And it's further reason to want to have some innate stuff. So one example is in these systems that just are driven by the data from like conversations and Reddit and so forth, you get weird effects like murder is more common than breathing, even though in reality, breathing is more common than murder. But people like to write about murder and breathing is born. So you have that problem. I'll just say one more second. And then people's internal mental states, we don't necessarily write that much about. There's some fiction where people are really kind of like third person omniscient and describe it. But in general, there's not as much data around that. So the paradigms we have work very well for things you can explicitly label a bunch of data, maybe you do some unsupervised learning on the rest. But, you know, like this is a picture of a cat and you've got a label for it. But things like harm, so having a robot not do harm, or understanding like a difference between like belief and desire and all this kind of stuff is pretty subtle to get from the data-driven paradigm. Not saying it's impossible, but those are some places that like out of the gate pose some challenges.
Yep. Gentlemen, we're out of time, but could I ask one quick lightning round question? How do you think educated consumers who are using, you know, variations on computer vision and natural language, word processing, all sorts of things related to AI, how should they think about AI? Should they roll along with the developments that touch their lives, or should they maintain a sort of skeptical stance to what's going on around them? What would be your very concise word of advice to the general thoughtful public who is dependent on AI already?
I would say, don't treat AI as magic. Understand that it's really an evolving set of techniques that have strengths and weaknesses. And you need to get your hands a little dirty to understand, will this work with your particular business problem? So we gave examples of like advertising versus driving versus domestic robots. It's an empirical question in any given domain. Is this going to work for you? It's not magic. You can't just assume it's going to work. You shouldn't assume it's not going to work. There is a lot of gold in these hills. There are a lot of ways that you can make things more efficient and so forth. But you really need to dive in and learn how this stuff works if you're going to make good decisions around it.
I think getting educated and understanding the specifics is probably good advice. But I do worry. I think in general, I worry about also sort of being aware and where AI is seeping into your world, particularly with regard to you know, recommendation systems, and probably like in terms of how it's managing the content that you are getting pushed. I think it's just, that's a big issue for us today.
Yeah, I think the worst thing that AI has done so far is to polarize society with content moderation, which was driven by AI. So, you know, there are pluses and minuses to AI so far, and that's one of the biggest minuses.
Understanding the roles playing in content moderation is sort of a very poignant thing.
Yeah. Gentlemen, that is extremely good counsel. Thank you for your time. Incredibly lucid and helpful conversation, I think, to everyone at SiteTech Global. Thank you again.
Thanks for having us. It's fun for us.
Who knew that AI is so dumb? I mean, who knew it could be so smart and dumb at the same time? Which is kind of ironic because as a teenager, my dad used to ask me that question all the time. Thank goodness we've got good people like Gary Marcus and David Ferrucci working to make a smarter AI. Our next session is about a special kind of AI called computer vision. You may not realize this, but when you use your Seeing AI app and it identifies that it's a couch in front of you, that's computer vision. Also, those fancy cars out there, the Teslas, they've got computer vision in them that tell them when they're approaching an object and something's in front of them. Computer vision, though, it's going to be going through some changes. Our moderator is Cecily Morrison, Principal Research Manager at Microsoft Research. The session is called Computer Vision. Did it just get smarter or worse?
Did computer vision AI just get worse or better? Moderator Cecily Morrison, speaker Dana Gurari.
Thank you very much, Brian, and welcome, Dana. Tell us a few words about yourself.
Yeah, so I've been an assistant professor now for just over 5 years, and I'm currently in Boulder, Colorado. Beautiful place, University of Colorado Boulder in particular. And I focus on both teaching and leading a research group. So insofar as teaching, I focus a lot on educating the next generation on how to build large-scale data sets to train modern artificial intelligence algorithms. I also spend a lot of time teaching them how to design these algorithms that consume that data so they can go and do something impactful in the world and hopefully help society. And so complementing that teaching background, I also lead a group of about typically 10 students from undergraduate all the way up to PhD level students on designing machines that can see, and we call that discipline computer vision. And for the past, 5 years, 7 years, we've focused predominantly on thinking about how do we design computer vision algorithms to be in the lives of people who are blind or visually impaired to help them overcome their visual challenges in their daily lives.
It's such exciting work and very relevant to our audience here. Tell us, innovation in AI has been very rapid. We hear lots of new things coming out. But can you share with us the latest trends?
Absolutely. I think it's helpful in talking about the latest trends to understand where we've come from. So I mentioned in my teaching load that I teach students how to make large-scale data sets to train modern artificial intelligence algorithms. The status quo from about the 2000s up until 2017 was a technique called supervised learning. And the idea was you would have humans label data. So let's imagine we want a machine that can recognize cats in images. You would have humans go and look through a bunch of images and label which images have cats, which ones don't. And with those labels, you could feed that to the algorithm, and the algorithm would learn patterns of what's present when cats are present and what should not be there when cats are not present. And that was the trend up until 2017. On humans was the bottleneck. It's time consuming, it's costly, it's relatively slow. Jump forward to 2017 and the natural language processing community. So the community that thinks about how do we design algorithms that can analyze text. And I said, well, let's not rely on this supervision. Let's just rely on the data itself. And the idea that was proposed was, let's, for example, have machines read books, and we have all the text from these books. And all we're going to do is we're going to mask out single words, and we're going to teach the machine how to predict the word that was masked out. And so all the text is available. We're just going to randomly mask out different words and say to the machine, predict what was there that I made disappear. A year ago, the computer vision community caught on to this trend and said, wow, this is brilliant. We can move beyond relying on humans to label data. We can take advantage of the mass repository of images and videos on the web to make machines that can see, and do it with a similar approach. Given an image, we want to predict if it has a cat, mask out little blocks of the image that have cats. Do that in the video, and have the machine learn how to predict the presence of these kinds of things with parts of that visual content masked out. And it turns out that this kind of training of algorithms leads to performance that far exceeds what we've ever seen before. So it's really, really a revolutionary concept that has changed the landscape of what is possible, because we just have so much more data from which algorithms can learn to recognize patterns.
Wow, and it seems really quite new in the computer vision space. What do we call this new phenomenon?
So the flavor of these algorithms are called transformers. And so that's kind of the architecture that is developed, and the approach for training these methods, these transformers, is called unsupervised learning, which is in stark contrast to what we had, which was supervised learning through human labels.
I get it. So the supervised bit is where we need to tell the computer what things are, and the unsupervised bit is where we're trying to get the computer to figure it out. Did I get that right?
Yep, with no human annotations at all. That's the idea.
That's a major transformation. So this sounds great, but how is this going to be useful for many of the people watching this conference who are blind or low vision, or building technologies for people who are blind or low vision?
Absolutely. So there are several different use cases we need to think about for our audience. And one is where we have people who rely on their phones, smart glasses, whatever, in order to learn about their visual surroundings. So we know things like Ira, Be My Eyes. We have all these kinds of services that help people in their daily lives learn what they're going to eat for breakfast, whether they're choosing the clothes they want, how to cross the street in a safe manner, and so on. And so we have this tremendous amount of data that's being collected, but again, it's costly for these companies to label these. And the companies that I mentioned, such as like Be My Eyes and Ira, while they are very powerful players in the space and are changing people's lives, it takes a lot of money to get humans to label this data. And so it's limited what can be done insofar as getting the appropriate funds and the time that takes to label. And so you can imagine these companies taking advantage of transformers, training them without any supervision, without any human labeling on the data they have. And all of a sudden, we can imagine algorithms that are designed for data collected from our target audience. So rather than data that's widely abundant, traditionally what's available on the internet, that's generally what's being used for training these algorithms. We can instead say, let's train these algorithms on the data for our target audience. And for sure, when we focus on the data coming from our audience, we would imagine improved performance. So that's one use case that I would imagine create great advancements on, and that would allow us to hopefully move away from exclusive reliance on humans to having more automation in the loop. And I imagine that's helpful for when we're dealing, for example, with people's private information, or just people need really fast information and don't want that human connection. And then the other situation, I think, is just going to be an extension of what we've already been seeing. We have things like Microsoft providing captions for their PowerPoints and various productivity applications. And so continuing to see more alt text that's automatically generated for things on the web, whether it's products from Microsoft, Twitter, images, and so on.
So it's a great concept that there are lots of things in the world that we can use these transformers to recognize, but how do we start to build systems that really put the user in the driving seat of those systems?
Yes. So this is also a space where transformers can have an impact in thinking about how do we do personalization. So one thing I did not mention is that these transformers are not being trained to perform one task. Their effectiveness comes from the fact that we train them to do like 5 different tasks, or 10 or 20 or 100 different tasks at once. So as an example, use cases I've seen from our audience of people with some kind of vision impairments is, give me a description of an image, or answer a question about an image, as 2 examples. And so modern transformers, the way that they're being developed is that we are training them to do a huge number of tasks. And by training these types of architectures to do a huge number of tasks, they're learning to be more like humans that can generalize and do many things. So they're not designed to just say, I recognize cats. They're saying, I can both describe when is cat available, I can answer questions, I can count, I can, just the number of tasks they're being taught to do is incredible. And that creates a broader level of intelligence that allows them to generalize what they know to novel use cases. So maybe they learned what a horse looks like, and they've learned to recognize black and white. And so next time they see something that looks like a horse but has black and white stripes, they can say, that's a zebra, even though I've never been taught what a zebra is. And so this space of being taught this huge number of different skills and learning to generalize what they're learning, such as colors with, detecting things like horses, will enable them to work well in novel scenarios where they were not originally trained. That is called either zero-shot or few-shot learning, which means take knowledge you have, and without having to get a lot of unlabeled or labeled data, learn to generalize to these novel use cases. And once we do that, we can start opening the door to personalization to individual people's needs. Because now we don't need to keep training from scratch a brand new algorithm to meet each individual's needs. We can just kind of provide what we call prompts in this space. And that's a bit of a technical term that I'm going to gloss over without going into the details. But the idea is we can prompt these algorithms without having to retrain it to be able to generalize to novel use cases that would be specific to each one of the users. And so for me, I think that that's one of the exciting next steps that we'll see in this community is how do we personalize to each individual's needs? Because, you know, if you lose your sight when you're born versus later in life, you maybe have different prior understandings about the world. If you have some vision, that might change your needs versus if you have, you know, no residual vision. And so I certainly envision that we will see these transformers keep helping us move closer to this acknowledgement that really there's different needs that need to be met. And we don't want one size fits all algorithms that behave exactly the same for every user.
That makes a lot of sense, because even if people are in a single community, it doesn't mean they're really the same. But let's go a little bit deeper on these things. So the kinds of examples you're giving are things like how it brings together knowledge about the visual world. So one of the things that we see within technologies in the blind community is that I have one app for navigating certain intersections, and I have one app for navigating maps, and I have one app for recognizing colors, and another app for, you know, recognizing barcodes, and another app for, you know, and the list goes on, right?
Yes.
You know, most people I know are using multiple apps in a day to do these different visual tasks. So it sounds like, well, Transformer is maybe one of those things that are going to bring those visual tasks together. But
absolutely.
Then how do I know how do I work with that system to get the particular visual task I need at that time? How do you see this happening? Is this something that's going to happen by itself, or is this something where a user is going to become skilled in working with these systems to kind of get the visual information that they need?
I think it's going to be a combination. So as I mentioned, these transformers are really in their infancy. We're starting to learn that there's this ability to do personalization through these things called prompts. And so we don't fully understand how to leverage these prompts with these kinds of architectures. What do I mean by a prompt? It means that you start with letting the algorithm know this is what I'm looking for. So you can imagine saying, here's an image, color. And that would be the prompt you give to the machine, and the machine will say, I see in here yellow with some black and green, okay? You could have a different prompt that says, is there a person in your view? In the case that we're looking at me, the answer would be yes. We can have another prompt that says describe, and it would say, oh, I see a woman who has shoulder length brown hair, who's wearing a black shirt, has headphones on, right? You can imagine these different prompts that you give, and the machine through this widespread training, all these kinds of different tasks through a lack of supervision, will learn when I see a pattern of this kind of a prompt, such as the word color or visual question or caption, this is how I should respond. And so similar to kind of how you would prompt like a child or an adult to do something, we would see a similar thing in these architectures. And so there's going to be learning about how do we come up with the appropriate prompts where we are getting the responses we want. So that's going to be part of it, but there's going to be a dance, because in that learning about these algorithms, we're going to learn about the struggles and prompting them correctly and where they misbehave and where they just do things we don't want them to do. And so we're going to have to redesign the underlying architectures. And so there is going to be a dance back and forth that will continue at least for the next 5 years, I envision, because this is, again, you know, this is a 1 to 2 year old concept. And so we're going to have to dig more and more into understanding what is it these machines understand, right? Like what do they want us to say in order to respond the way we want them to? And how do we make sure they're doing them ethically? So how do we make sure that they're making responses that are in line with what we think they should be, as you know, in contrast through a bias, you know, like answer the question is, what color is my banana? Most of the time when we see a banana, it might be yellow, but sometimes it's brown, which means it's rotten. And we wanted to learn to say, I recognize the color of a banana, rather than just the pattern that whenever I see a picture of a banana, it should be yellow. Most of the time, so I'll say yellow. So there's going to be a lot of work also on just verifying that these algorithms are really responding based on the appropriate cues they should be, rather than just on biases. And there's certainly going to be a lot more work around ethical development of these transformers.
Gosh, there's a lot of nuggets that we can pull from there. So let's dive in a little bit more to some of them. So you said 5 years. That's not very long.
I mean,
what are you thinking? Tell me.
So let me just give you a sense of the size of the communities that are working on this. When I started my PhD back in 2010, the computer vision research community, the number of people who were going to the mainstream conferences, was somewhere around, I think, 1,000 or 2,000 people. The last time pre-COVID that I went to one of these conferences, so I think that was maybe in 2018 was when I went, they sold out and there was about 10,000 attendees. And the community is growing. We are seeing that across the board in all these various artificial intelligence communities. We are seeing a dramatic growth in how many people are coming onto this buzz. We are seeing this in the classrooms. My course has been the most popular course at my university. It maxes out. We have long waiting lists. And so we are just seeing a wild amount of people just diving in onto this trend. And so what's happening is we have so many people around the world who are working on pushing this space forward. And when you have that amount of human effort coming in, for sure, I think you can see progress just moving so much faster. There's money, millions, billions of dollars going into this. Self-driving cars is an example, right? Like that industry alone is huge. And they are looking at this kind of technology. And we are seeing this across the board. So I think just the sheer amount of money and human effort focused on this kind of problem means that we can see progress faster. And that's where my belief is. It is also, my belief also stems from having watched the advancements from the past decade. I mean, it's astounding how fast we're moving, but it's because it's been working and it's becoming more and more popular. It's a snowball effect. And so I don't think that snowball is quite at a point where we're slowing down yet.
Yeah. So this is moving really fast. We know that people have been thinking about some of the challenges that we need to think. We have efforts going on in responsible AI that think about the kind of biases you were talking about with the banana. But how do these challenges change with these kind of big models? I mean, you talked about them, they could do so many things, but I guess that also means they can do a lot of things maybe wrong.
Yes, so many things wrong. So, you know, the challenge I described with the banana is the machine even looking at the image or the visual content? In that case, if you see a bunch of images and you get a sense of what, you know, the color yellow is, then you can just have a machine spit out, well, almost all the time, you know, 85% of the time I see a yellow banana. So I know 85% of the time I'm going to be correct when I see one. So I'm just going to say that because I'm usually right. And that's a good way to gamble. So that's what these machines are doing. And so there's ways we can encourage machines against that kind of biases. One thing we can do is we can start to inspect the insides of the machines. And so one of the buzzwords I did not throw out about these transformers is they have this module called attention, which means it's kind of one of the keys that enables these architectures to work really well. But what it also means is that these machines are learning where to attend in images. And so we can say, are the machines looking where they should be to make a prediction? Or are they looking at surrounding evidence? And so we can do that. We can use that kind of attention to dig in and try to get a sense of, are they really reasoning in the way we think they should be? And if not, we can start to penalize these algorithms. We can start to put punishments when we train them for not looking where they should. That takes a little bit of supervision. So now we're getting back into that tension we have where we are asking for humans to be involved in labeling so that we are ensuring, you know, a more responsible direction, but that's going to happen. This is true for language. So let's say you are trying to translate. I would imagine in our audience, we have people who speak different languages and come from different countries. And you have some countries that have gender built into their languages and some that don't. And so a popular example, I believe, is in if you translate from Turkish, which I believe doesn't have gender in it. If you translate like something like the person is a doctor into English, you'll see it says he is a doctor in English. If you translate the person is a nurse from Turkish into English, you'll see it's she is a nurse. So the assumption is she goes with nurse, he goes with doctor. That's another kind of bias that we are seeing from these kinds of models because of many reasons, including the data they're looking at perhaps had systematic biases from history that are being fed forward. And so again, we have to create some sort of human intervention where we have checks. We say we know these kinds of biases are possible, and not even possible, they have happened. So let's go through and systematically test our models to say what are the biases that are present. And when we see certain ones, we go and retrain it to penalize having those kinds of biases. And for sure with our target population, there's already published literature talking about the biases that are imparted on people with any kinds of impairments, any kind of disabilities. A lot of the literature that is being used in the self-supervised learning approach has built-in biases about people, for example, with mental illness. There's just these generalizations that these models are learning about people with mental illness are more likely to go to jail, and these really horrible kinds of perpetuated stereotypes that are often found in the material that's being used to train models. And for sure, I imagine we'll find these kinds of issues about really inappropriate generalizations about people with visual impairments. And so we're going to want to understand what are those kinds of stereotypes that we might see from the data that these models are being trained on. How do we test against those? How do we verify that we are not putting systems out that embed these kinds of stereotypes? And that takes a lot of just engagement with the data as well as engagement with our target populations to uncover where could these systems go wrong.
So as you know, we're looking towards the future, but actually a lot of these simpler AI systems are out there for people to use now. What can they learn from some of the things you're saying about just getting the best out of the systems that they have now?
Yes, I think it's good to be skeptical if you are using automated systems, even human-based systems. It's good to, have some sort of internal check and ability to do some sort of internal quality control. That's not always possible, right? If you say what color is something, then it's not necessarily the case that if you have no vision, you can make that kind of judgment. But, there's certainly a health, maybe you can ask a few more questions to see, does this machine have internal consistency? So maybe you ask the machine in different ways the same thing, and you say, does the machine consistently arrive at the same outcome or not? And if it's not, and that's a critical question for your health, safety, whatever, then maybe you go find another option, a human-based option, because you can assess through multiple probes that the machine's not behaving a certain way. Of course, that doesn't feel like a viable solution for the long term. We can't spend our lives probing and probing and probing forever, but certainly up front, we should do that.
So just as an example of that, like if I have a medicine, so maybe my app can recognize objects, so it's recognized that it's a medicine, but maybe I also then want to go check with my short text recognizer what actually it says it on the label. Is that kind of what you mean, where you're using two different AI systems to make sure they're giving you the same result?
Thank you for the clarification. And I'm actually suggesting something different, which is we have a single model that's going to be providing us the information. And so you can imagine saying to the system, tell me, what is this object? If the answer is pill bottle, okay, we have some confidence. But then we don't stop there. We say, is this a pill bottle to the machine? Does it say yes? Or does it say no? Then we say, if we have confidence that it's able to, detect the right object, then we might say, how many, what dose am I supposed to take? And then it gives you an answer. You say, 5 milligrams. And you say, am I supposed to take a 5 milligram dose according to this? And so basically figuring out how to probe the machine with slightly different ways of trying to get the information. You could just say, give me a description of the image. Does it give you a description of, this is a pill bottle that you're supposed to take 5 milligrams? And so basically probing it with slightly different variants of what you're looking for and what you're hearing to make sure there's internal consistency in how it answers. Because if it's not internally consistent, there's a higher likelihood it's just spewing out biased responses and that it doesn't have logic that it's working from based on what you're giving the machine. Does that clarify?
That makes a lot of sense. Yeah, thanks for the example, and I'm sure that will be appreciated by the viewers who are making sense and using these systems. In the few minutes that we have left, I want to close with a question, which is: you have a long history of improving computer vision for people who are blind or low vision, but which of the contributions of the many you've made do you value most?
Yeah, great question. So I think I'm going to try to hit on 3. I know you said the most, but I'm going to maybe spread that over to 3 series of events, which have kind of reflected how my career has gone. When I started my work in this space, I really felt that as a single researcher, I really was not going to be able to change the world for this audience. And that was important to me. I was raised with the idea that my mom would lose sight one day, and she had many eye issues. My whole family, we've always struggled, and so it was always really a personal drive to try to feel like I could make a difference for something that felt pretty close to home. And so feeling that I, as one researcher, would not be able to have a huge impact, I said, well, instead I'm going to do what is called making a data set challenge. So basically I went out starting in 2015, and I was able to obtain data from people who are blind, and I was able to label that data to support a bunch of different tasks, such as answer the question about an image, describe the image with a caption, tell me if the contents of the image are recognizable or not, and if not, then we can prompt the photographer to take another picture. So basically I went out and I started to create all these what I call data set challenges, and I invited the broader computer vision community to come and compete on these challenges. So I said, I'm not going to develop the solutions. I'm going to develop the foundation and let everyone in the community come if they want and compete. And they have. We've had over 100 teams, so I'm guessing hundreds of people who have come and helped push forward the level of performance from these algorithms. And for me, there's no words to express how awesome that feels to be a part of that kind of momentum, to have helped facilitate that kind of growth. And it's not just in the development of algorithms, it's also the presence of the number of people who are familiar with the needs of people who are blind and low vision, right? By accessing their data, implicitly, they're getting some sort of training about what kind of solutions are needed out there. So I'd say that's the first level of work that I did that I'm most proud of. There was a series of things that followed from that initial effort. So in hosting these dataset challenges, we would have announcements every year at the premier computer vision conference, where again, there's 10,000 attendees that come in theory. And so we would host this workshop as part of that event where we would announce, here's the winners for these challenges every year. We started that in 2018, and that was really cool because all of a sudden we had people who are needing the work done showing up and saying, here's what I want from you. And we were creating kind of this dialogue. In that process, we also discovered there are major barriers to having inclusion of people who are blind and low vision within the computer vision community. And within the larger artificial intelligence community. It's not just the computer vision community. And so just by trying to invite our audience, we found there was issues with registration along the way. There was screen reader issues, like screen readers weren't working on these websites for conferences, and we still know that. And so by discovering that, now for the first time this year, we have created a new position for the conference called the Accessibility Chair, and I have a chance to now go in and help through supported funding from the leaders to start to make a more accessible community. And so I'm really, that's just starting. I think many people in the audience will appreciate change takes a long time, but I'm really excited to be a part of this change to hopefully allow for this community to be more inclusive to people who are blind and low vision. And so hopefully we can have a lot of attendance from this population going forward, where in the past it's just been not even thought about. And so I would say, in closing, being a part of this community and helping create a more inclusive world has been the more recent aspect that I'm really excited about.
It's so important that when we do these things, that there's nothing without us, nothing about us without us. So it's great that you haven't just stuck to the technical side, but embraced the whole of it. Well, I have learned a lot, and I hope the audience has as well. So thank you so very, very much, both for what you gave us today and for your larger contributions to the community.
It's my pleasure. Thank you so much.
I think it's important for people with disabilities to stay on top of important topics like this, computer vision. And thankfully, we've got two great people keeping track of this, like Cecily and Donna. We have one more AI session coming from another angle. Whether you know it or not, AI tends to categorize us. You might not approve it, you might not like it, but it does do it. We're very fortunate to have Yuta Trevanius moderate this session. She is the director and founder of the Inclusive Design and Research Center. This next session is entitled AI Decision Systems Permeate Our Lives. Now what? Over to you, Yuta.
AI decision systems permeate our lives. Now what? Moderator Yuta Trevanius. Speakers Merv Hickok and Clayton Lewis.
Welcome, Merv and Clayton, to this session of SciTech Global. It's wonderful to have you both here. And I'm not going to introduce the two of you. If I really did your introduction justice, it would probably take all of our time, and we have so many important things to cover. I think suffice it to say, we all have thought long and hard about how do we make decisions about the nature of human and machine intelligence, and we're worried about the risks of the current course of innovation. And we've devoted our careers to finding more inclusive trajectories. I wonder if you want to add something relevant about your particular background, Merv and Clayton.
Absolutely, and I'll be very brief about it. I'm the founder of AIethicist.org, and my work focuses on bias and social justice in general. And also the research director at Center for AI and Digital Policy, so working on the policy, advocacy, and regulation side of AI and algorithmic systems. And I also work for an organization that develops and uses learning systems for individuals with intellectual and developmental disabilities. So a lot of complementary work, and thank you for having us here.
Yeah, I'll mention that I was drawn into an interest in current developments in AI in my former role as co-director for technology at the Coleman Institute for Cognitive Disabilities. And in pursuing possibilities for using AI to support people with disabilities, I was really led to learn about very recent developments, which are, I think, really transformative. Potentially, we hope for the good, but there are also risks.
Thank you, both of you. So for decades, I've been worried about the impact of statistical reasoning on people who have lives that are different from the statistical average or norm. Now the same reasoning is made more efficient, accurate, and consistent through the pervasively deployed artificial intelligence systems. What are the implications of statistical reasoning applied in current AI systems? And how is this compounded by recommender systems that encourage affinity grouping? Wendy Chun's contention is that current AI systems mechanize eugenics and segregation. How does this play out? Merv, I wonder if you can comment on this, given your role.
Yeah, absolutely. And let me start with, there's already a difference between our ideal world of just an equitable world, right? We don't know society in the world gets to live that optimum state. We have our biases, we have our discriminatory histories, and in our society, as well as our structural biases in the institutions, and still trying to resolve those. So all the data that we're looking to work on that relates to human interactions of consumers or citizens or humans in general with different institutions, carries that injustice and equity. And what we do with that data is then replicating, if you're not taking precautions and safeguards, or maybe even take the option of not launching an algorithmic system or AI system, what we do is kind of replicating and deepening and magnifying those injustices of the past as well. How these biases, especially against what is called as outliers or differences from the statistical norm, is we build these systems usually for without much consideration of who is on those who is on the tail ends of those statistical distributions and what their experiences are. And in terms of real life experiences, for example, if you're not recognized by a system to make it work for you or work it optimally as it works for a lot of other people, you might be encountering physical, psychological, emotional harms and repeating harms at that. You know, it's not just once or one system. You have that repeat in multiple systems. Or you end up trying to fit into the system's expectations of trying to change your accent, your pronunciation, your pitch, eye contact, smile posture, you name it. You're shifting yourself to fit into those expectations. And worst case, if you're considered an outlier or error in the systems, it means that you might not be getting the opportunities such as jobs or education, or resources such as housing, insurance, loans, etc., that others in the society get to enjoy, and someone is making those decisions for you by function of this creating the systems and expectations and norms in those systems.
So a lot of people think AI is something of the future, but can you tell us a little bit about how pervasively it is employed? What decisions is it making for the companies and the governments and the schools that we interact with?
Absolutely. So AI or algorithmic systems make decisions in housing, and who gets housing, with tenant screening systems, or who gets to have housing benefits if you're getting it from if you're getting any government benefits, and to that effect, all the other government benefits at federal or state level or in different countries, national level. We depend on these algorithmic systems now. In school education, in education systems, access to schools, access to job opportunities as we're going through hiring processes, performance management processes, or productivity scores. We see this in health decisions on who gets to be prioritized for crucial health interventions or health diagnostics at even for certain use cases. We see it in policing, law enforcement, border control, immigration, asylum and refugee systems. We see them in credit scoring of who gets to get a credit in the first place, or at what, for example, interest level that you get that credit. Similarly, loans, do you get it, or what kind of loans you can, what kind of insurance that you can get, what kind of coverage, or at what levels, etc. It even we even interact with them in pricing of the products that we buy with recommender systems and pricing systems, what kind of news that you get to see, and as well as other opportunities and interesting things. So these systems are making decisions, especially the recommender systems, but what you get to see, what you get to experience, and how do you access these systems and opportunities as well.
And possibly even influencing how you say things, what you send to people, what you share, what you don't share.
Absolutely.
Yeah. So people with disabilities are often used as the poster child of AI innovation, the ability to recognize images and tell whether you're going to go and take the wrong pills or go into the wrong subway entrance is life-changing. But even there, if your world is not the world the system is trained on, what are the implications? And is it likely to recognize and work for you if you are in an unusual context?
One of the issues with, especially since the systems are dependent on the data sets that are built on them, as well as the what you train the system or what kind of use cases you've included. If you treat especially abilities and the spectrum of abilities as this homogeneous thing, one, you might be missing on a number of disabilities. You might be missing on different manifestations of abilities and disabilities, and you might be missing on the intersection of like how these disabilities manifest themselves, or how do you get to experience that and in different contexts, in different cultures, in different locations as well. So there's a whole host of complexities that go into the systems, or should go into the consideration and development of these systems in the first place. So even if you're not, even if you're, you think that you have a representative data set, there are still a lot of assumptions in your thinking that you're representative or your data set is representative. So if you, to your point, Jutta, if you're interacting with the system in a way that doesn't recognize the way the system was trained, the comment is different, the light behind you is different. If it's, for example, a computer vision system, or the sounds or background sounds or the pitch, etc., is different, or even the way that you pronounce or put a sentence together is different, the system again might not work for you. So I think there's a lot of work to be done in terms of the assumptions and not treating especially a lot of our identities as homogeneous identities to start with, but especially in the case of disability, there are a lot of different manifestations, intersections, and considerations that need to go into that.
Yeah, and the effect of the bias is cumulative, isn't it? I mean, if most of the training happened in a typical middle-class neighborhood with typical middle-class products, and you try to use a recognition system in a, say, rural setting where the products are not typical, the neighborhood is not typical, what's the likelihood that it will be as accurate as it is in the trained environment? So what happens is there are all of these interacting cumulative effects in terms of who it works for and who it doesn't. Is that also your perception?
It is also my perception, and I use the concept of like cumulative disadvantages, a coin that was termed a while ago, but my interaction with it is through Oscar Gandhi. I use that a lot because I tend to draw like long-term implication, or I tend to try to figure out the long-term implications and harms in any system. You know, what happens if disconnect is, if something is connected to other. So in this case, I'm really concerned about these systems becoming interconnected with each other. So as you interact with, for example, banking, insurance, loans, housing, employment, whatever, these systems become interconnected, and one biased result or one harmful result from one system becomes interconnected and becomes a bigger problem in another system. Or things that you don't have control over, you're disadvantaged and harmed, and you just go deeper into that disadvantage whole, whether we want to do that, conceptualize as that, or conceptualize harm, for example, as a snowball. It just keeps building on each other, and it becomes a vicious cycle. So if you're not considering these harms in each of these systems, as well as their interactions, we're creating a very bleak future where we are permanently locking people out of resources and opportunities.
So you mentioned representation, and there's now a proliferation of AI ethics companies that will audit and certify your AI as ethical. And one of the things that they attempt to address is data gaps, or in fact, what's called data deserts. Are those going to, are they effective? Because what's happening is that companies are spending quite a bit of money to measure the AI ethics and to receive a certification as being ethical. Do you think this addresses the issues that we've been talking about, the cumulative harms?
I think there's definitely a step in a positive direction, but that is definitely cannot be the only solution or only control over the systems. And these audits, these criteria, these controls, checks and balances also need to include the people who are impacted by the systems, right? A lot of the time, we're talking about someone coming in, using this criteria or the models that they build, audit models that they build to assess without having that experience or knowledge of different kind of harms and how they manifest as well. But there is also the piece about, in general, setting the audits aside, when we use statistics, we're dependent on quantified data, right? But not everything is quantifiable, and not everything is easily quantifiable. So it means that as you build these algorithms, as you collect this data, you make decisions about what counts as a measurable proxy for the behaviors and interactions that you're interested in. It also means that we may not be able to capture the qualitative elements of what makes us humans, the complexity of our choices, behaviors. It means we're attempting to capture that fluidity and complexity of the experience, but without success, hence creating a whole host of harms and biases. And if I may here, I might be throwing a bit of a additional curveball here, kind of moving away from the audits maybe, but also here, kind of moving away from the audits maybe, but also for me, there's the element of a very problematic tendency of treating some constructed concepts, such as race, as something biological, as something quantifiable, as something objective in itself. We first come up with these political concepts or social concepts such as race, for example, which actuality denotes difference between individuals. And we forget about histories. We forget about our discriminatory histories, where these concepts and constructs were used in what context, for what political purposes they were used. And then we come as statistics, which has a lot of historical baggage in itself. We come to statistics and try to treat these concepts as scientific, unbiased, impartial categories and technologies. So for me, there is already that, from the nature of it, there are a lot of issues that we need to consider when we're depending on data, depending on statistics, depending on models, and add on top of that all the other assumptions and decisions that we make. Audits and certifications come at the very end of that, and you already have a huge pile that you need to work through, and how you audit that and how you certify that, and whether we should is a whole different question then.
Yeah, I'm somewhat worried about the false assurances and the dismissal of the bias that you've been talking about. And certainly in our modeling, even if we get rid of all of the data gaps, even if we have full proportional representation and we remove those areas that you're talking about, the human racism, sexism, and ableism from the algorithms, we still have the issue of statistical reasoning and its bias against those outliers and already excluded minorities that are not part of the training set. And that takes us, I think, to your topic, Clayton. There are emerging systems within AI which do not use statistical reasoning, but with every new innovation that is going to disrupt our lives, there are risks and opportunities. So Clayton, what are some of the risks and opportunities of the emerging large language models that don't employ this statistical reasoning? Do the systems have the potential to ameliorate some of the discrimination against outliers and differences that Merv was talking about? What do you advise, or what can you predict?
Yeah, maybe before going directly into that, I wanted to maybe reflect a little on some of what Merv was saying and step back and note that any system that's trained on data of past decisions, which most of these systems are, they have the property that they kind of tie us to our past. And as people, we should be thinking about our aspirations. So not what we've accomplished, but what we aspire to accomplish. And I worry that these systems really hold us back from that and say, well, we're just going to reproduce what we've been doing. We're trying to tune it up a little bit. And
all data is from the past.
Yeah, and there's a connection there. So these large language models, things like GPT-3 and its many successors, have some properties that may offer some real benefit here. These systems have the feature that they can at least appear to do something like reasoning, and they can process not just actually they're better at processing sort of assertions and propositions rather than data in the traditional sense. So they don't run off tables of cases. They run off large volumes of text that embody things people have said about things, and remarkably, this includes inferences. So that means that these systems, like people, may be able to operate at the level of aspiration and policy in addition to the level of what experience has been. Indeed, as they are now, it's not really possible to sort of load in a bunch of data about past hiring decisions. But I think the fact that can't be done now, that's temporary. I'm confident there are already a few systems emerging that have the ability to consult data as well as to process propositions, sentences, policy statements, and so on. So we can imagine systems that will be much more like people than current systems are, in that they can operate at both levels. They can respond to historical data, but they can also respond to assertions, ethical values, policy statements, and things like that. So that may sound pretty good in that they may deal with they may indeed deal with some of the issues that Merv has laid out, but there are a lot of uncertainties and therefore risks that remain. So one thing is, as these systems are now, they're quite inconsistent in their judgments. That may not be all bad, actually, but from some points of view, it's a serious limitation. But for me, there are risks in a couple of areas. So one is we don't understand how these things work, and so it's going to be difficult to be confident that they will act according to some ethical aspiration that might be stated. For example, we don't know how reliable that behavior is going to be.
They're even more inscrutable than.
Sorry?
They're even more inscrutable in some ways. Yes.
Yeah, that's right. We have very little insight into how they work in particular cases. But a feature that they have that I think exposes another category of risks is they are clonable like other digital systems. And that means that there's the potential, and this relates to Merv's interconnection concern. There's the potential that instead of having, as today, many different people making decisions about, for example, hiring, we may reach a situation where there's really a single system that's making huge numbers of these decisions with all the risks that are entailed there. So I'm concerned about the lack of diversity going forward, which again has the feature of kind of tying us down. So instead of allowing us to flexibly respond as our aspirations change, as our experiences change, I worry that we'll be dealing with large systems that are operating everywhere and that we don't understand very well, and that will be difficult to change.
Yeah, and especially as they cost so much to create, which means only very large, powerful players are able to create the original ones, which then can be transferred. So that may mean that we're encouraging an even greater monoculture. One thing you mentioned about training and the additional opportunities for giving instruction. I'm a professor, and the first course that I teach in my program is called Unlearning and Questioning. This is a graduate course that is necessary to overcome the years of socializing the students have been exposed to. Among the things to unlearn is the notion of average humans, the social Darwinist notion of survival of the fittest, the sorting, labeling, and ranking of humans, and the idea of quick wins by ignoring the difficult things in the 80-20 rule, and also the folly of ignoring the entangled, complex, adaptive system we live in when we plan and predict. All of these are deeply embedded in the data or the training language or the data sets that the systems are trained on. How do we teach the systems to unlearn this? I mean, if we're handed these large language models trained on mammoth amounts of scraped data, how do we go about having the same unlearning and questioning process?
So I think as of now, we just don't know how to do that. You can find efforts in the literature. People are trying to find ways of diminishing false beliefs and so on, but these are dealing with pretty simple things. How we could cause a statement of an aspiration, say a policy aspiration of non-discrimination, to speak in very simplistic terms. I don't think we know how to make sure that a policy or aspirational assertion like that outweighs what might otherwise be happening in the system based on other aspects of the training. It'd be a little bit optimistic. It's very early days for this technology, and it may be that we'll be successful in developing an understanding of all of that and that we can become more comfortable about it. But that seems pretty far off as things are now. And so there's a worry about the applications of these things outrunning, as usual, our ability to really understand them and their implications.
Right. And I mean, we usually encourage scaling by diversification and contextual customization. One of the positive things that has been stated about these systems is the ability to transfer, to change context. Are you optimistic that that might ameliorate some of the issues with the monocultures or the transfer of this cumulative effect?
Well, I think those things operate at different levels, really. So I think these systems are already showing a remarkable ability to transfer, so to speak, patterns of relationships from one domain to another. It truly is amazing if people have played with these systems. But I worry that won't mean that we won't have a monoculture kind of system. Whatever the ability of a system is, it may be that's the system that large numbers of people end up using, and so that won't mean that we end up having a diversity of perspectives. But yeah, I mean, well, yeah. Period. I'll leave that there.
So to both of you, what should people in the accessibility community watch out for and advocate for individually and collectively as these systems emerge?
Well, let me go first, but I want to say one thing about that on learning and possible to teach that to the systems. We see some unsuccessful attempts by technology companies to put fixes in place, right? Like where you see language models or computer vision or search algorithms, etc., trying to fix some of those biased results by certain patch fixes, which ends up, again, you're making determinations or you're making judgments about what should be fixed and how it should be fixed. And the result becomes people talking about their religion, people with disabilities talking about their disabilities or their identities or their experiences are marked as toxic or dangerous speech. And they're, again, biased and discriminated against. So I would be very curious of how, like, who gets to decide what should be unlearned and how should be unlearned, and to apply those to those systems. But in terms of your question on, what should we advocate for individual and collectively, I want to come back to the issue of cumulative disadvantages and interconnected systems. This is not only for the accessibility community. This is for every one of us in different ways, because we all have experienced our identities, different parts of our identities, whether it's age, ability, sex, gender, religion, you name it, in different ways. So as these systems become more prevalent in our lives, they're going to be yet more impactful and connected. So I think it goes for all of us to kind of individually advocate for acknowledgement of these harms and ask for legal remedies and safeguards and a control mechanism where some systems should not be launched or used in certain contexts to start with. And now for collective advocacy, I want to highlight two things. One is the, again, intersectional identities and power, which comes from the intersectional identities. We can advocate and innovate better and create better if we understand those combinations and different dimensions that make each of us connected. And second, a lot of the conversation on AI ethics and policy are still very much Western-centric and prioritizes Western values. Similarly, a lot of the major data sets that we use, the systems from large language models to computer vision to object identification within that, are also based on Western societies and Western cultures and Western languages. So I think collectively we can advocate for bigger connections and wider communities and insights and kind of try to go beyond our own circles. And if we're acknowledging that if we're experiencing harms and bias in one context, that especially in the Western in the Western countries systems, that there's a higher risk of those harms and damages in outside of that circle, and how do we get in front of that before catastrophic issues happen?
Right. Yeah. Recognizing our differences and valuing our differences. Thank you. And Clayton, I wonder if you have advice.
Yeah. Actually, I wanted to link to an argument that Phil Agri makes, more than one, in his paper, Surveillance and Capture as Models of Privacy. So he warns against capture, as he calls it, which is the tendency for automated systems or computerized systems in general to displace human agency. And that's what we're talking about here. So in the name of efficiency, we're taking ourselves as people out of key decisions we make about one another. And we're, of course, flawed, but we're flawed in ways that offer hope for progress. of a sort that I don't see in the increasing adoption of these automated systems, where people are not they're abdicating responsibility and make judgments about other people as humans to systems whose basis has the kinds of problems that we're talking about here. So I think we all, as people, really need to push back as much as we can against this idea that somehow decisions shouldn't be made by people. They should be made based on data or on automated systems or whatever. Because I think we are marginalizing ourselves and doing a lot of harm in the process.
Yeah. People over efficiency, consistency, and automation, right? Yes. Thank you so much. And unfortunately, we've run out of time. There's still so much to say, but hopefully we can continue this conversation at another time. And thank you for bringing both of your perspectives.
Thank you for having us.
Thank you.
Thank you very much, Yuta, Clayton, and Merv. Believe it or not, we're coming up to our last session for this year's SciTech Global. And this session is near and dear to the heart of every blind person or anyone who can't drive. Now, I wasn't blind as a kid, so I actually drove when I was much younger. And I got to tell you, driving, it isn't about driving, it's about independence. I was also, once I went blind, on Top Gear USA. And they had me do something which was known as drifting. It was a drifting challenge. At the time when I did it, it was the scariest thing I've ever done. But at the end of the day, when I was alive, it was the coolest thing I've ever done. And thanks to technology and the advances they're making, I can't wait to get behind the wheel again one day. Next, we're going to hear from Waymo, who has a fleet of self-driving taxis that anyone could hail from a smartphone app. This service is up and running in Phoenix, and this session is called What Waymo Learned at the U.S. Department of Transportation Inclusive Design Challenge. Our moderator is Mike May, one of the most beloved and admired tech innovators. He's an evangelist for good maps, as well as a lot of other things.
What Waymo learned at the U.S. Department of Transportation Inclusive Design Challenge. Moderator Mike May, speakers Lauren Schwendeman and Jeffrey Colin.
Thank you, Brian, and thank you, SciTech Global, for having this forum for discussing some of the latest and greatest technology. This is Mike May from Good Maps. I've worked on accessible navigation a good portion of my professional career. And when we turned into this century, I think Uber and Lyft and rideshare were some of the greatest things that happened in terms of independence for blind people, not to mention everybody. And the Holy Grail has been, when can I drive a car? And in a Consumer Electronics Show press conference in 2009, they asked Stevie Wonder and I together, what's your greatest dream? And we both said, being able to drive and control a vehicle on our own. So we're thrilled to have Waymo here to tell us more about that, and then to have feedback from a couple of users from the San Francisco Lighthouse to tell us about what it's like to be in a vehicle, which I haven't done yet, but I have lots of questions about how it all works. So let's do a quick round of introductions and then we'll dig into it. Lauren?
Hi, everyone. I'm Lauren Schwendeman. Thank you so much for having me. I lead the experience design team for Waymo One at Waymo. So our team is responsible for designing all the interactions that riders have with Waymo's ride-hailing service, from hailing their car in the app to finding their car, boarding, riding, exiting, and finding their final destination. And I'm excited to be here to talk about our DOT Inclusive Design Challenge.
Yeah, thrilled to hear more. And certainly at Good Maps, we use LiDAR for indoor navigation, and LiDAR outdoors was a big part of, I think, a lot of the technology that allowed this sort of thing to happen. And it facilitated the indoor navigation that we do. So I'm really interested to hear more about that. Jeffrey?
Hi, everybody. Thank you for having me. My name is Jeffrey Colon, Director of Access Technology here at the Lighthouse. On Access Technology, we provide individual and group training to blind and low vision users throughout the Bay Area. We also provide user recruiting and corporate training to different organizations, such as Waymo. So we partner with them on this exciting project, recruiting users and working with them on making sure that they have the opportunity to participate on a great users research study. Thank you so much for having me here.
Yeah, thank you, Jeffrey. And of course, the Lighthouse and Good Maps are working together, and we hope to have a BART station accessible soon.
Yes,
MacArthur
sir.
BART. Yeah.
Yes, sir.
Shane, how about you?
Hi, guys. My name is Shane Martin. I've been living with sight loss for about 6 years now. A proud member of the Lighthouse family. Looking forward to continuing all my experiences and work with the Lighthouse. Everybody's been great, and I've enjoyed working on this Waymo project, and it's been a journey for sure. So I'm looking forward to helping wherever I can. So thanks again.
Yeah, thanks for being on here. Lauren, tell us about the design challenge and what is that all about? What was the request in that that challenge that you guys decided to meet?
Yeah, sure. Thank you. So the DOT Inclusive Design Challenge was really an opportunity for us at Waymo to pursue and embrace universal design by learning from people with a variety of needs and disabilities to ensure that we're building a transportation service that works for everyone. So for our particular entry into the challenge, we really looked at the wayfinding user experience. We explored product prototypes geared toward touching a variety of senses that incorporated accessible audio-visual, haptic, and hands-free features and tools to support riders throughout their journey with Waymo. So we also worked with community organizations, notably Lighthouse for the Blind and Shane, who's here, to test these prototypes and hear directly from people with blindness or low vision how well different solutions meet their needs and can support their independence in ways that really work for them in their everyday lives. So the prototypes we tested were like I said, mostly focused on wayfinding and really sought to answer the question, how can we make it easy, safe, and convenient for all of our riders to know where to meet their car, how to navigate to their car, and to board their car with confidence. And then at the end of their journey, how can we help them get to their final destination safely, confidently, and independently? So that's just a quick overview. I'm happy to dive into more of the details of the prototypes, but just wanted to kind of give a high-level view of what we were aiming to do.
Yeah, I think before we pass it over to Jeffrey, I think a lot of people would just want to know, what is the state of autonomous vehicles? We all hear bits and pieces, particularly if there's a catastrophe, but I think the technology has been evolving for quite some time. How long has it been in process, and where are we in terms of the industry?
Thank you for that question. We've actually had a lot of exciting announcements happen over the last few weeks for Waymo. So first of all, autonomous vehicles or, Waymo autonomous driving has been real for Waymo for the last 2 years in Chandler, Arizona, real meaning available to the public. But as of late, we've announced that LA is our next autonomous ride-hailing city. We've begun testing at Sky Harbor, which is the airport in Phoenix, Arizona, one of the busiest airports in the US. And we've opened up our service, our Waymo One ride-hailing service in downtown Phoenix to the public. And hot off the press, we now have our permit to operate in rider-only mode with members of the public in San Francisco as of today. So we're really excited about the momentum that we have, and we're working hard every day to make the promise of AV ride hail real for people to use in their everyday lives.
Okay, good. Well, we'll come back to a little bit more about that and also what's next. Jeffrey, having not used the app or the experience myself, I'm just curious, is it like rideshare where you just launch an app and you put your pickup location and your destination and a car shows up? How does it all work?
Yeah, it works like that. And I wanted to also have a little context of when the experience that we have when Waymo approach us to with working on this great user study. Like Lauren said, they wanted to make sure that how that we can provide feedback of blind users on all areas of the experience, like from the beginning when we request a vehicle, like you said, Mike, making sure that a user can find the buttons on the applications. How do we make sure that we can provide feedback for different perspective? So when Waymo came to us, we decided, okay, let's approach this in the way that we approach our user studies. This is very important for our community. So let's find users on different skill set of access technology. Let's find a probably 65, 70-year-old man that is starting with technology. And let's see how this person can contribute on providing feedback of working or finding a vehicle. Let's find a 25-year-old very tech-savvy user that can provide those technical aspects, those areas. Okay, I wanted to make sure that I understand, that I can cancel, that I can change my ride, that I can find different alternatives. Let's find these 45-year-old women that are in the middle. So we try to find all different skill sets of users and combine that into an opportunity to be the liaison with the community and Waymo to help them approaching that part that Lauren mentioned, finding the car, making sure that it's safe, that people find this experience accessible. So I even was part of the initial pilot and tried to, okay, the first part, finding the application, making sure that swipes left and right, finding the buttons, those parts were accessible. So we have an idea when we approach the users of how to find, and we find people like Shane that help them getting that feedback that they need to see how the project was progressing.
Yeah, and how many people were in the study?
We found we did three rounds of the study. We did one that was for the users to find the car, and the other two was on different aspects of the application. So in the first round, we found 12 users.
Okay. So you mentioned that figuring out how do you find the car, and this really speaks to one of the hugest problems with rideshare. You have a situation where you have a sighted driver that's looking for a blind rider. But at least that driver, if you text them or call them, you can say, "Oh, I'm over here. I've got a dog," or "I'm next to a sign." But that's always a challenge to connect with that vehicle. How does that work with an autonomous vehicle? You don't have anybody to call.
Yeah, so for us was okay. Let's obviously the classic ones, pick up, drop off, and then it was the experience, the application telling us, okay, now the car will be, it started the wayfinding feature like Lauren mentioned, and try to direct you in like using wayfinding alternatives, like you will be 200 feet from your right. And then you start walking in, and the application, when you were getting closer to the car, it will be like an experience like you are using a maps application, like Google Maps, that it will tell you that you are 100 feet away, 50 feet away. And then when you get closer to the vehicle, you will present with more options, like the opportunity to even run the honk, so you can hear it. And that was very interesting. And the users that participated with the study that had that opportunity, when they get closer to the car, they will have opportunity. So I know that people that Shane has that opportunity to see how it when they were closer, that experience, because you know that sometimes is those last 50 feet is the challenge for us.
Yeah, the final frustrating 50 feet, the bane of all accessible navigation. Yeah, I was hoping you could honk the horn. That would be great.
It was super great having
that. It could be a bit crazy with a lot of people after a concert or something. And I suppose there's probably some way to flash the lights for sighted people.
Yes, that was also part of the experience.
Okay.
Too.
Okay, good. Shane, how did you find literally find the car?
It was interesting. It was something that I hadn't expected to be quite as easy. You guys touched on the tones, the signals, which was super helpful. I was lucky enough to have people with me, so I wasn't too worried about, being panicked or not finding it. But it seemed really easy. We crossed the street and walked right up to the car, and it went pretty smooth. I was impressed, thankful.
Yeah, is there any option? This might be getting a little bit fancy, but can you tell the car, come to me? I mean, if they're on the other side of the street, you may not want to cross. Can you communicate that?
Right. I don't think we went over that. Trying to think back, but I don't remember calling the car. I remember going to the car. I remember ordering the car and going to it. So I was going to the mountain instead of the mountain coming to me, I guess.
And what about once you got in the car? Tell us about that experience.
Smooth as well. Everything, once you shut the door, everything seemed comfortable. I was always kind of hesitant about getting in the car without a driver, but it seemed pretty easy, and the whole experience was comfortable, and it seemed like it would have been a great ride. I wish I could have taken a ride in it, but maybe at some point.
So you just got in and kind of sat there and checked it out. Does it provide any sort of progress report or announcements saying, 1 mile to my destination, I'm passing Starbucks, or any kind of play-by-play like that?
That would have been great, but I didn't get to ride in it. So I got to go to it and get in it, and then so I didn't get too much after getting to the car. I didn't get to experience too much.
Yeah. Lauren, is that something that's available or will be available?
That is actually a setting that we have available that people can turn on or off, is like more verbose audio cues to help support understanding what's, landmarks that you're passing and what's going on with the ride and how the driver is making driving decisions.
So once I'm in the vehicle, am I interfacing via the app to know what's going on and how to maybe change my destination? Or is there a switch over to a big screen in the car and control panel there?
No, do you have the app? Do you have the app? I was doing it through the app. And like Lauren said, you have the opportunity to change it through the app. Like you usually can change any ride, but also you have the opportunity to interact, and you hear the car mentioning different, like if you activate the verbose option, then you will get opportunity to hear some of the destinations when you're passing different areas.
That's right. Obviously, as Jeffrey mentioned, you can interact with the app to control every part of the ride. There's also a screen in the car. Should folks want to interact with a screen that shows visually information about what's going on in the trip and supports some some visualizations of what the car is seeing and responding to in the environment. And that screen has some controls as well, but we really see it as a priority feature to have every control accessible in the app, so that can be a primary interface for folks.
Yeah, the more any kind of app can parallel the sighted experience with the blind experience, the better, just in terms of updates and sharing user experiences and helping each other out. What had to be adapted for blind users, other than making sure the buttons were accessible, the obvious things? Was there anything else like the horn honking that had to be added, or that could actually be helpful for a sighted person as well?
Yes, that's one of our hero examples of how universal design has really improved the experience for everyone. So Our honk horn feature has been available in the app for some time, and we've seen usage of that feature from a variety of folks, blind and low vision people included, who really rely on it. But we've seen everyone really appreciate that feature in helping confirm where their car is, or they know that it's nearby, but it could be behind a building, and just have the ability to leverage that sense to hear or to find your car has been really useful for everyone. There's a feature that can minimize walking time. So the car, that some people is important for some people with different abilities or disabilities or mobility challenges, where the way that our car navigates to a pickup spot is influenced by a variety of factors: the route time, the traffic patterns, etc. And so there is a setting where if it's really important to you to minimize your walking as much as possible, you can tell the Waymo app, minimize my walking. And it might take the car slightly longer to get to you, but if that's important to you, that's a setting that's available. I'll also add that one of the features we tested in this research, which was around better app navigation to find your car. So I think Jeffrey was mentioning, like, your car is 50 feet straight ahead or to your right. There's a voiceover experience, and we built this compass-like interface that could give these verbal directions to support blind and low vision usage. But we've also seen that everyone really loves the simplicity of this feature, because it's a very human way to give directions to someone versus trying to follow dots on a map or lines on a map. Just hearing or being able to read and see, go 50 feet to your right or 30 feet straight ahead. That feature has also been talked about by a lot of our users as being super useful. So that's another example.
That's certainly my world in terms of accessible navigation, and particularly in indoor settings where we give turn-by-turn directions. You don't have streets and sidewalks and parameters that guide where you're going, so you need to be really good about giving a slight left or hard left or right or turn here and there. So that sounds like it's the same sort of thing in order to navigate to your car. It just crossed my mind in terms of cars honking. Most cars just have one kind of horn. I'm just wondering, could I send a flag to the car that's, this is Mike's honk profile? I could even use Morse code or something.
Very interesting. I remember, they actually, when we tested, as far as I remember, probably they even added more profiles. It was more than one sound. So every time that we pressed the button, it was a different sound. So sometimes, especially, that's very important when we talk about universal design for different users that maybe they have some problem with different frequencies, and maybe they could not detect that sound among a crowd of people. So I remember we talked about during the feedback sessions, and they actually implemented, I remember hearing more than one sound. So it will be more opportunities for people that could have some problems identifying those sounds to have opportunity of hearing a different one.
Right. One of the things I've always wondered about when I'm going along on my journey and something goes wrong, there's a traffic jam or something breaks down. Now I'm in the middle of the road. I'm a blind guy by myself. I'm sure you've talked about this experience. What do I do? Sit tight? I obviously can't get out and go walk to the nearest gas station. What kind of safety parameters are in place to deal with that kind of situation?
Great question. So we do have rider support available via a button in the app and in the car. And this connects people to a human agent right away, who can see where your car is and understand what's going on in your ride, and be that human-to-human kind of interaction and help you understand what might be going on and or help you resolve any unforeseen situations. And so we've also found that aspect of our service to be really reassuring and helpful to people to know that, okay, I'm in this ride, I love the privacy, I love so many aspects of it, but what happens if something unforeseen happens, and that's where I think rider support is that great kind of backup, extra help, extra support as needed.
And Lauren, is the thinking here with autonomous vehicles that the world of rideshare right now doesn't really share that much, but the idea of making more use of a car because it picks me up, it drops me off, then it goes and gets somebody else. It seems like that's a more effective sharing type of approach to using motor vehicles.
Yes, I mean, a service like Waymo One, is accessible in a variety of means, meaning like, folks don't need to own a car to use it to get from point A to point B. And so I think, it allows us to share resources among the community, and leverage the technology, and make it available to everyone. So yeah, I believe that the ride-hailing model really does, make this really exciting, important technology available broadly to the public, and that is our vision that we're working toward.
Yeah, Shane, let me pass it back over to you for a second. What's your thinking going forward? Or I'm sure you're excited about this. Or do you have any concerns? What are you thinking about the future?
100%. I want to go back to what somebody said earlier. I just want to say that you don't have to be 75 to be technologically challenged, believe me. But everything seemed to be pretty smooth and good on that end. But the one thing that stresses me the most and makes me most anxious is getting there before it times out. Your driver's leaving in 2 minutes or whatever, and that's always my biggest fear, I guess, about is missing it. And I don't think I've asked about that during my time with it. So that's what stresses me the most. Is there a time limit? I'm sure there has to be, but how do you handle that on your end, I guess, or how do you address that?
It's a great question, and that is actually one of the learnings that we had from this research and that we've seen. So Shane, you're not alone. We hear that a lot. That
great.
Knowing, there's stress involved in finding your car and getting to it before it drives away, and in particular for folks with disabilities. And so this is an area where we're really excited to explore what we could possibly do to mitigate that, or to, again, reassure people that they won't miss their ride. So that work is in progress, but that feedback has been heard loud and clear.
Great.
Yeah, interesting. But with so many technologies, it really takes years from when it's proof of concept and you can do cool demos. I think of voice speech recognition. I worked on a project in 1981 at Bank of California where we're thinking, well, within a couple of years, you'll be doing banking by speech. And it took another 25 years or more. Indoor navigation, I started working on that in 1996, and it's just now becoming viable. Where are we in that evolution of autonomous vehicles? How long have they been going, and what can we expect? I'm sure there's a window or an estimate, and you have to have lots of caveats, but what is the future coming forward?
Yeah, no, I think it's a question on a lot of people's minds. So just to answer one of your early questions, Waymo, which was formerly the Google self-driving car project, began in the late aughts. And so we've been working in this problem space for I don't know, 15-ish years. I don't know the exact number, don't quote me, but we've been working on this in this space for a long time. And how real is it? It's real today. We're operating in Phoenix, an urban city, publicly. Anyone can download the app and take a ride. We're expanding in LA and San Francisco. And so we really believe the future is here. Again, we work to deploy responsibly and in line with public policy and all of those good things. But we really see this materializing today for real people in their everyday lives. So we've been working for a long time to make it real, but we do feel like now is the time where it's people can use it.
The future is now, and Ned and I are going to head to Phoenix and check it out in person. We'll go ahead and wrap up, and thank you, Jeffrey and Shane from the San Francisco Lighthouse. Wonderful having your thoughts, and I'm sure you'll be contributing even more to Lauren's work.
Thank you.
Thank you so much.
Yeah, thank you, Lauren. And I'll hand it back over to Brian. It's been a pleasure being on here. Mike May from Good Maps. Have a good day.
It's a pretty amazing world that produces a self-driving on-demand car for people like me. Let's hope Waymo keeps developing this even further, because while I might not be able to drive 55, hopefully one day Waymo will allow my self-driving on-demand car to drive 55. I hate to say it, but we're at the end of this year's Site Tech Global. I hope you've enjoyed it, because I've really enjoyed being your host. Before I sign off, I'd really like to thank our sponsors of Site Tech Global, iSenpai, Fable, Amazon, Google, LinkedIn, Humanware, Microsoft, Ford, APH, and Waymo. I'd like to give the final word to Alice Turner, the head of corporate and community relations at Vista Center.
Hello, Site Tech Global. My name is Alice Turner, and I am the Director of Community and Corporate Relations for Vista Center. My journey with Vista Center actually began back in the 1990s. I was working at that time for a large organization in the Bay Area as the Training and Development Manager. And so for me, I have a congenital eye condition. And what that means is that all through growing up, through school, through college, through establishing my career, I had a progressive loss of vision. And what that meant for me is that I needed to adapt and cope, until I no longer had the skills to adapt and cope. And that's when I turned to Vista Center. It was one of the best decisions of my life. What Vista Center and the highly professional staff did is that they taught me access technology, how to travel safely, how to manage my life, how to manage the daily living tasks. But most importantly, they gave me back the competence and the confidence that I thought that I had lost forever. So essentially, I was retooled. And then I returned to my job. I loved my job for another 8 years as a blind professional. After a little bit of time, I decided to contact Vista Center to do what I thought was going to be volunteering. And as it turns out, there was a position that was open at that time. That was 14 years ago, and I joined the Vista Center staff. And currently I serve as a senior manager on the leadership team. One thing that my journey taught me is that access technology levels the playing field for people who are blind or visually impaired. I am sure many of you in the audience know this as well. So with this in mind, several years ago, Vista Center started a corporate partner program. Through this program, We serve as consultants and subject matter experts with many of the technology companies that have been represented on the stage during this conference. We provide them with the information and the expertise from a research point of view to see if a product is viable, or to establish if an existing product needs to be modified for people who are blind or have low vision. I have had the privilege of working on the planning team for SiteTech Global, and through this development of the conference, I know that the relationships that we have established with the companies represented on this stage will continue long past the event. So I ask you, has your curiosity about access technology and AI been piqued throughout this conference? I certainly hope so. So I want to thank the technologists, the designers, the researchers, and the advocates who have so passionately brought their expertise to the stage and shared their information with us. And I also want to thank the generous donors and sponsors. Your donations go directly to Vista Center, and that will enable us to serve the thousands of individuals that we serve every year. And I want to thank you as a participant for joining the first SiteTech Global. And I invite you to come back for every subsequent SiteTech Global that we will have in our future. So thank you.
That's a wrap. Thanks for joining the event. See you next year. That's a wrap. Thanks for joining the event. See you next year. That's a wrap. Thanks for joining the event. See you next year. That's a wrap. Thanks for joining the event. See you next year. That's a wrap. Thanks for joining the event. See you next year.